Ladies and gentlemen, registration is now open and we kindly invite all participants to complete the registration process at the front desk because the conference will begin shortly. Thank you very much. And once again, I would like to ask you that registration is now open and we kindly invite all participants to complete the registration process at the front desk because the conference will begin shortly. Thank you very much. Begin shortly. Thank you. Ladies and gentlemen, distinguished guests, registration is now open and we kindly invite all participants to complete the registration process at the front desk because the conference will begin shortly. And I ask all of you, all of ladies and gentlemen are also distinguished guests to entering the room and also please kindly be seated. Thank you very much. Ladies and gentlemen, please give a big round of applause and warm welcome to our Ministry Menteri Pekerjaan Umum Bapak Dody Hanggodo. Good morning and also welcome. It's an honor for us to greet you in this special conference. Please kindly be seated. Good morning, ladies and gentlemen. On behalf of the organizing committee, it's my honor for me to welcome you to the first International Conference of Construction Innovation with the theme of Bridging Vision and Reality for a Sustainable Construction Future. Let's give a big round of applause. Thank you so much, ladies and gentlemen. This special conference is hosted by the Politeknik for Public Works, and we truly appreciate your presence today. It's an honor for me to meet you. I'm Reza Violentina, your Master of Ceremony for today's conference, and I would like to say good morning and also welcome to the Honorable Menteri Pekerjaan Umum Bapak Dody Hanggodo. Direktur PUTEK Politeknik Pekerjaan Umum Bapak Insinyur Brawijaya SE MEGI MSCE PhD IPU ASEAN Eng. Para pejabat tinggi pratama di lingkungan pekerjaan umum and all of distinguished guests, ladies and gentlemen. Ladies and gentlemen, before we begin the program, we kindly request your attention to a brief safety induction video. For your information, this venue is equipped with comprehensive safety facilities, and the video will explain the location of emergency exits, evacuation procedures, and essential safety guidelines to ensure everyone will be throughout today's event.
Selamat datang di Politeknik Pekerjaan Umum Semarang. Sesuai dengan peraturan perundang-undangan dan prosedur keselamatan di gedung ini, maka seluruh tamu, pengunjung maupun yang beraktivitas diwajibkan mengikuti safety induction agar memahami dan menaati seluruh peraturan mengenai keselamatan kerja dan keamanan selama berada di gedung ini. Saat ini, Anda sedang berada di lantai 2 gedung Auditorium Suyono Sosrodarsono. Di setiap lantai telah dilengkapi dengan kamera pengawas keamanan dan sarana fire protection yang jumlah dan posisinya telah disesuaikan dengan kebutuhan keselamatan gedung. Jika mendengar alarm darurat, jangan panik dan tetap tenang. Segera tinggalkan gedung ini dengan mengikuti jalur evakuasi menuju titik kumpul atau assembly point yang berada di bagian depan dan belakang gedung ini. Selama proses evakuasi, selalu ikuti petunjuk dari petugas yang membantu Anda dan perhatikan beberapa hal berikut ini. Gunakan tangga darurat. Anda tidak diperbolehkan menggunakan lift. Dahulukan ibu hamil, orang tua, serta penyandang disabilitas. tetap berada dalam kelompok di Assembly Point yang berada di bagian depan dan belakang gedung ini. Hingga ada petunjuk berikutnya dari petugas penanggulangan darurat. Demikian petunjuk keselamatan dan keamanan ini. Ikuti dan patuhilah petunjuk tersebut untuk keselamatan kita bersama.
Ladies and gentlemen, to officially begin our event today, please welcome Tari Geodeno that will perform by Sofia Salsabila, Sabania Dina Ramadhani, Elsia Salsabila Ramadhani, Eva Saputri, and Eka Safia Ramadhani. This then portrays the joy and vibrant spirit of the young generation, their dedication, openness, and continuous pursuit of innovation. It reflects their ability to adapt to changing times with creativity while upholding noble values. All of these elements represent a real commitment to preserving our cultural heritage. So, let's give a big round of applause. This is Tari Geodeno.
Recording in progress.
Okay, ladies and gentlemen, please give a big round of applause for the dance performance of Dody Hanggodo. We will now sing the Indonesian national anthem, Indonesia Raya, followed by the Works Pekerjaan Umum. And to commence our program respectfully, may I invite all of guests to please stand up. Ladies and gentlemen, please kindly be seated. Ladies and gentlemen, and all of distinguished guests, for the next agenda, we will hear the report from the Director for Public Works Polytechnic. So, to Bapak Insinyur Brawijaya SAMA, EEMSCA PhD IPU ASEAN, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya. Salam kebajikan, good morning, and may peace and prosperity be upon us all. The distinguished attendees, the Minister of Public Works of the Republic of Indonesia, Insinyur Dody Hanggodo, MPA, the first and second echelon high-level official within the Ministry of Public Works, the rectors, directors, and leaders of higher education institutions, the organizing partners, the keynote speakers, Professor Indratmo Soekarno, Professor J. Haur Chen, Professor Takafumi Nishikawa, Professor Gan Buntara Stanley, Dr. Alwin Commander, the invited speakers, Professor Muhammad Arif Budiharjo, Professor Rini Kusumawardani, Dr. Reyes Garcia, Rian Mantasa Salve Plastika MT, and Yuni Asih Nurhidawati MSc. And last but certainly not least, all the distinguished guests, presenters, lecturers, and students. First and foremost, let us offer our utmost gratitude to God Almighty because of His blessings and grace. We are able to gather today in good health to attend this event, the first International Conference on Construction Innovation, ICCI 2025. Dear ladies and gentlemen, our distinguished guests, the construction sector is a key element in achieving sustainable development, especially amid rapid urbanization and climate change. In response to these challenges, a vision has emerged to reshape construction practice to be more sustainable, resilient, and technologically integrated. However, we recognize that the realization of this vision is often hindered by various systemic and practical challenges in the field, ranging from fragmented institutional coordination to uneven technological adoption. This gap underlies PUTEC initiative to organize an international conference with the theme Bridging Vision and Reality for a Sustainable Construction Future. Dear ladies and gentlemen, our distinguished guests, this event is organized with the following objectives. First of all, to facilitate knowledge exchange among academics, practitioners, and policymakers, particularly the one regarding the implementation of Industry 4.0 technologies in the construction sector. Secondly, to bridge the gap between theory and practice, aligning the vision of technology with on-the-ground realities. The third, to encourage the emergence of innovative solutions for sustainable and resilient infrastructure development. The fourth, to strengthen international collaboration and network in research and vocational education. And the fifth, to support human resources development so that our students and professional workforce are prepared to adapt to rapid digital transformation. This event is held for one day at PUTEC campus in Semarang. To ensure academic depth, this conference features leading experts. The plenary session will feature 5 international keynote speakers, namely 1. Professor Takafushi Nikisawa, University of Nagasaki, Japan. 2. Professor Indratmo Soekarno, Institut Teknologi Bandung, Indonesia. 3. Professor J. Haur Chen, National Central University, Taiwan. 4. Professor Gan Buntara Stanley, Nihon University, Japan. And Dr. Alwin Commander, Royal Haskoning, the Netherlands. Then, 12 parallel sessions will be held discussing 85 papers. The parallel sessions will include presentation by the invited speakers, namely Dr. Reyes Garcia, Warwick University, the United Kingdom. 2. Rian Mata Salve Prastika, MT, University of Queensland, Australia. 3. Yuni Asih Nur Hidayati, MSc, University of Kent, Belgium. 2 of them are from lecturer from PUTEK, Politeknik Pekerjaan Umum. The 4th, Profesor Muhammad Arif Budiharjo, Universitas Diponegoro, Indonesia. And the 5th, Profesor Rini Kusama Wardani, Universitas Negeri Semarang, Indonesia. This event is conducted in a hybrid format, offline and online, and is attended by 950 participants from various backgrounds, including the central government, local government, the private sector, academia, the general public, and our proud PUTEK students. Through this diverse global perspective, I hope that this conference can provide a tangible contribution to the advancement of Indonesia's infrastructure. Ladies and gentlemen, our distinguished guests, in closing, I would like to extend my highest gratitude and appreciation to the presence of the Honorable Minister of Public Works, all the speakers, and all the attendees here. That concludes the report that I can deliver. Now we would like to kindly request the Honorable Minister of Public Works to deliver his remarks and officially open this event, the first International Conference of Construction Innovation, ICCI 2025. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the Director for Public Works Polytechnic for the report that just delivered. Ladies and gentlemen, next we will hear the remarks from our Minister of Public Works, Bapak Dody Hanggodo. Your Excellency, the stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning everybody. May peace, mercy and blessing be upon us all. The Honorable Directors of the Polytechnic of Public Works or PUTEK, Pak Brawijaya, all the senior and primary high-ranking official within Ministry of Public Works, the expert council of the PUTEK, the chair and members of the advisory council of the PUTEK, the directors, deputy directors, senate members, and all of the Civitas Academia of Polytechnic of Public Works, the keynote speakers, the invited speakers, distinguished scholars, industry leaders, innovators, community representatives, members of the media, students, and all the brilliant young minds joining us today in the first International Conference of Construction Innovation or ICCI in 2025. It is actually a profound honor to welcome you all to this first international conference on the construction innovation in beautiful auditorium of Polytechnic Public Works. This ICCI is hosted by the Polytechnic of Public Works, or we can call it also the PUTEC. The PUTEC itself are known as our National Living Laboratory for Infrastructure Excellence. Today, we gather under a theme that is both an aspiration and also as a responsibility, bridging vision and reality for a sustainable construction future. This conference is more than a gathering of experts. It is a convergence of multi-disciplines, ideas, and generations, positioning Indonesia not at the margins, but at the front line of global construction innovation. Ladies and gentlemen, to understand the future, we must also understand the forces shaping it. We have today currently already entered the era of the Industry 5.0, where human creativity and technological intelligence must move in harmony. And yet, the global construction sector continues to face deep structural challenges, high-risk operational environments, significant material inefficiency and waste, fragmented workflows that delay delivery, limited adoption of digital tools and automation, shortages of certified future-ready workers, and also low integration across disciplines and supply chains. These challenges are not merely about technical issues. They are systematic barriers to national competitiveness, to the climate resilience, and also sustainable human development. So, the Industry 5.0 demands a construction ecosystem that is safer, smarter, cleaner, and profoundly more adaptive. Distinguished guests, ladies and gentlemen, through this event, we have engaged in a insightful discussion and share innovative ideas, all of which strengthen our collective resilience through sustainable infrastructure in facing global challenges. Indonesia today steps into the next decade guided by the His Excellency President Prabowo Subianto, that we call it as a Asta Cinta, the President Asta Cita, the 8 missions program of His Excellency President Prabowo Subianto to steer Indonesia towards sustainable growth and unity for the golden Indonesia within 2045, or the Indonesia Emas 2045. As its heart, the Asta Cita is a doctrine of resilience, food security, energy security, water security, health and education, territorial equity, green, blue, digital economic transformation, and strong governance with national stability. And beneath of all these 8 pillars, one foundation holds the nation together. It is the infrastructure. Infrastructure is not the outcome of development. It is the enabler of development. It is the platform upon which every aspiration of the Indonesian people depends. Excellencies, esteemed scholars, lecturers, researchers, practitioners, students as distinguished guests, it is the platform upon which every aspiration of the Indonesia people depends on. To transform this Astacita into measurable national progress, this Ministry of Public Works executes 5-year strategic framework that we know as the PU 608, anchored on 3 national targets. First of all is reducing the ICOR, reducing the incremental capital output ratio to below 6. Secondly is the eliminating the extreme poverty. And the last one is driving the national economic growth toward 8% within 2029. These targets do not merely describe economic ambition. They define national readiness, inclusivity, and also the resilience. For this year, 2025, the Ministry of Public Works has infrastructure development targets. We have laid out tangible infrastructure main outcomes, including some of the presidential instruction and community-based infrastructure. On water resources sectors, for instance, we built multi-purpose dams and irrigation networks spanning tens of thousands of hectares for food, water, and flood control resilience, and also some other projects. To improve connectivity, we built and upgraded roads and bridges, including some flyovers and also underpasses. To promote sustainable human settlements, we developed communal sanitation and waste systems. And also we built some strategic public facilities that live human development. These are not isolated projects. They are the operational expression of this Astacita infrastructure that transform life. The heart of today's messages lies in 7 pillars, a comprehensive framework defining how Indonesia will build future-ready, climate resilience, human-centered infrastructure. These pillars do not stand apart. They reinforce one another, forming a unified architecture of national resilience. Let me now explain about the 7 pillars. The first pillar will be integrated water resources management. Water is the foundation of human security, and therefore, water infrastructure must be the backbone of national resilience. Through integrated water resources management, Indonesia advances a holistic system that combines multi-purpose dams, modernized irrigation networks, sustainable groundwater management, and flood mitigation structure. These pillars strengthen the food security, stabilizes water availability, and builds adaptive capacity in an era of climate variability. The second pillar would be sustainable road and bridge for connectivity. Connectivity for us is not merely about transport. It is about bridging economics and unlocking the opportunities. Our focus would be on sustainable roads and bridges to ensure that mobility becomes more efficient, safer, and more climate resilient. The Semarang-Demak Toll Road, for instance, stands a model of an infrastructure that not only accelerate logistics, but also protect coastal communities from flooding, and an embodiment of infrastructure serving both economy, and resilience. The third pillar would be green and energy efficient buildings. Buildings shape human life. Accordingly, they must consume less and perform better and also improve well-being. Under this pillar, Indonesia emphasis into green and energy efficient buildings guided by a robust regulation and international standard. From excellence in design for greater efficiency, or what we call the EDGE, we certified one of the biggest mosques within the area, we call it as Istiqlal Mosque. We certified it to government green building frameworks. We currently champion a built environment that lowers emission, enhances comfort, and aligns with global climate goals. This is how we build for a low carbon future. The fourth pillar would be nature-based infrastructure for built environment. Nature is a powerful engineer. So by integrating nature-based infrastructure, we embrace solutions that work with the ecosystem, not against them. The plastic asphalt, the recycled materials, and also the 3R construction practices reduce environmental burden while increasing the performances. This pillar transforms waste into value and anchors infrastructure within the ecological cycles. The fifth pillar would be sustainable water supply and sanitation system. Access to a clean water and dignified sanitation is the fundamental to public health and human dignity. This pillar accelerates the expansion of sustainable water supply system through what we call the drinking water supply system, or in Bahasa we call it as a SPAM. We have built some SPAM. There is a SPAM Jatiluhur, SPAM Umbulan, and some other regional water networks. While also we strengthening community-based sanitation initiative. So waste to energy facility such as the Penowo project further integrate waste management with energy recovery, turning environmental challenges into the opportunities. The sixth pillar will be technology and smart infrastructure systems. In this era of this Industry 5.0, infrastructure must become intelligent. Under this pillar, Indonesia advances the technology and smart infrastructure system through what we call the BIM, or Building Information Modeling, from 8D to 8D. Digital twin modeling, real-time analytics, and also energy simulation tools. These technologies shift infrastructure planning from reactive to predictive, improving also the efficiency, minimizing the errors, and enabling smarter asset management across the nation. The last pillar would be climate and disaster resilient infrastructure. Climate change and disaster risk demands infrastructure that can withstand long-term climate stress and massive disaster risk. This pillar integrates adaptation and mitigation into planning and design, strengthening flood control, improving watershed management, reducing disaster risk, and also ensuring that infrastructure networks remain reliable under changing climate and disaster conditions. With all of these 7 pillars forming the backbone of our national infrastructure strategy, we now turn to the institution that nurture the talent and innovation needed to bring all of them to life. We call it the Polytechnic of Public Works, or PUTEC. Ladies and gentlemen, beyond the infrastructure, our greatest asset is human development competence, the capability of our own people. The PUTEC is Indonesia living laboratory, a crucible where research, testing, technology, and education converge together. Here, learning is experiential, innovation is continuous, and excellence is cultivated with a purpose. The PUTEC shapes the next generation of engineers, technicians, planners, and innovators who will carry the nation forward. Innovation must not remain just a concept. It must become capability. Vision must not remain an idea. It must become experience. Resilience must not remain a slogan. It must be engineered, tested, and delivered through what we understand as a hexahelic collaboration, a collaboration between the central, local government, industry, academia, communities, and media. Indonesia currently is ready to lead, to adapt, and to transform. This is why we gather today. This is why we always innovate, and also this is why we build. Allow me to close with a simple truth that reflects the purpose of this conference. The infrastructure is not merely about a structure. It is a bridge between vision and reality, between a nation, aspiration, and the everyday life of its people. Ladies and gentlemen, with the gratitude and conviction, with the blessing of the Almighty God, and with the good words, Bismillahirrahmanirrahim, I hereby declare the first International Conference on Construction Innovation officially open. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Santi, Santi, Santi Om. May peace, mercy, blessing be upon us all.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Mr. Dody Hanggodo. Please remain on stage to conduct the symbolic opening of the International Conference of Construction Innovation 2025. We will also like to invite Bapak Insinyur Brawijaya SA MNIA MSc PhD IPU ASEAN, accompanied by the head of BPSDM, represented today by the Secretary of BPSDM, Ibu Lina Anggraini, and also Ibu Esi Asia as the Secretary of the Directorate General of Strategic Infrastructure. Please kindly join us to the stage. We kindly ask you to face slide backward and place your hand on the LED screen, and then I will start counting. Excuse me, mister. We kindly ask you to face slightly backwards and place your hand on the LED screen to opening this symbolic conference. And I will start counting in. We kindly ask you to face slightly backwards and place your hands on the LED screen, and then I will start counting in 3, 2, 1. With this symbolic opening, the first International Conference of Construction Innovation is officially started. And I would like to request Minister of Public Works, Mr. Brawijaya, Ms. Linda, and Ms. Essie to please kindly move to the right side. Thank you very much. Ladies and gentlemen, to memorizing this incredible moment, we would like to take a picture together. So I would like to invite all of ladies and gentlemen to please stand up. We will take a picture together. Please stay put in your seat and please stand up. We will take a picture together. Ready? And we will count down in 3, 2, 1. Give your best smile. Thank you very much. Once again, 3, 2, 1. Give your best smile. Okay, and I will count down in 3, 2, 1. Okay, thank you so much, ladies and gentlemen. At this moment, we are honored to welcome His Excellency, the Minister of Public Works, to explore the exhibition featured at the first International Conference of Construction Innovation. We kindly invite the ministers to proceed to the exhibition area where cutting-edge technologies, breakthrough research, and innovative construction solutions from various institutions and industry partners are being showcased. Distinguished guests, please join us. We accompany the Minister on this exhibition tour. Thank you very much. The Minister of Public Works, Bapak Dody Hanggodo. This will be an excellent opportunity to witness firsthand the future construction investments that are shaping more resilient, efficient, and sustainable infrastructure for our nation and beyond. We respectfully welcome you to the exhibition area, where an exceptional array of innovation, advanced technology, and pioneering contribution from our distinguished exhibitors are being presented. This exhibition reflects the collective pursuit of progress, showcasing transformative ideas that inspire and elevate the standard of construction, infrastructure development, and sustainable engineering. Ladies and gentlemen, distinguished speakers, honored guests, and participants, today marks an important milestone as we gather to explore the breakthroughs, ideas, and transformative solutions that are reshaping the future of the construction industry. This conference brings together leading academics, industry professionals, policymakers, and innovators who share a common mission to push the boundaries of what is possible and to translate forward-looking concepts into real, impactful progress. Over the course of this event, we will engage in insightful discussion, learn from global experts, and witness the latest advancements that drive efficiency, sustainability, and resilience in the built environment. As we embark on this inspiring journey, may this conference serve not only as a platform for knowledge exchange, but also as a catalyst for collaboration and innovation that transcends borders. Let us take this opportunity to reflect on the challenge our industry faces, while also celebrating the remarkable progress achieved through technology, research, and creative problem solving. Together, we will bridge the gap between aspiration and implementation, vision and action, ideas and real-world change. We invite all participants to immerse themselves fully in the session, workshops, and discussion ahead, and to contribute their insight as we collectively shape a sustainable construction future for generations to come. Ladies and gentlemen, we will now proceed to the presentation session, and to lead the session, please welcome our moderator, Ms. Rizky Citra Islami. Good morning and welcome, Ms. Rizky. The stage is yours.
Thank you so much. Ladies and gentlemen, distinguished speakers, honored guests, and all participants joining us today, it's a pleasure for me to serve you as moderator for this important event, where experts, practitioners, and researchers from around the world gather to explore how we can transform visionary ideas into practical solutions to achieve a more sustainable construction industry. Today, we will have a discussion, the challenge, innovation, and also the collaboration to bridge the gap between what we aspire to build and what we can realistically implement. Today, we will have 5 distinguished speakers, and we try to divide it into 2-stage discussion. And for the first stage, we will have 2 speakers. Without further ado, we kindly invited Professor Takafumi Nishikawa and Professor Indratmo to come up to the stage. Please give a warm round of applause. From the online Zoom meeting, is there Professor Takafumi Nishikawa already joined with us?
Yes, this is Nishikawa speaking. Thank you very much for inviting me.
Okay, good morning, Professor Nishikawa.
Good morning.
Okay, is our voice clear enough?
Good morning. Hello.
Maybe it's too... Is our voice clear enough for you, Professor? Hello, Professor Nishikawa. Maybe the voices is... Could you please to lower the voices? Okay, maybe is there have any technical issue, Prof? Thank you so much for joining our presentation today. And for the first, we will have 2 speakers. The first will be Professor Nishikawa, and the second will be Professor Indratmo. Professor Nishikawa is come from Nagasaki University, and Professor Indratmo is come from ITB Indonesia. It's clear enough, maybe? Okay. Before we begin the plenary session, allow me to briefly outline the presentation guidelines for all the keynote speaker and participants. Each of the keynote speaker is allocated 25 minutes for their presentation, and a gently reminder will be provided when 5 minutes remain. Okay, Prof. Nishikawa will present the presentation related to the structure and how to bridging up the innovation for the sustainable construction industry. Maybe before we begin the discussion, I would like to open like a general question maybe for both of the speaker. But Prof. Indratmo, thank you for coming. And Prof. Indratmo is one of, we can call a funding father, Prof. Right? Funding father from the Polytechnic of Public Works. He is our first director, and Professor Indratmo also guiding us to help this conference. Okay, still have any technical issue? Okay. Or maybe we can move first to the Professor Indratmo first, or Prof. Indratmo first. Is that okay? Or we have to, Prof. Indratmo first. Okay, is it okay, Prof, if Professor Indratmo, okay, thank you so much. Maybe before we begin the session, I would like to read the curriculum vitae of Professor Indratmo. Professor Indratmo Soekarno is a senior professor of water resource engineering at Institut Teknologi Bandung or ITB. He is widely recognized for his expertise in hydrology, environmental engineering, and integrated water resource management. Also, he has contributed significantly to advancing sustainable water and environmental practices in Indonesia and the region. Professor Indratmo, maybe this is 25 minutes for presentation and the time is yours, Professor. Okay. The screen, please. Okay.
Okay, thank you. Distinguished guests, ladies and gentlemen, in the first session, I want to present about coastal reservoir. I think this topic is quite important right now because we have a problem with the shortage of water resources to fulfill any kind of water, mostly in the north coast of Java Island. It's better I try to explain directly. Next, please. I try to divide our presentation into 8 sub-chapters. The first is about introduction. The second, I try to cite one of the items in Astatita mission. It is because it is national mission for during these 5 years. And then I would like to introduce what we call coastal reservoir. And then technical aspect, I would like to explain any consideration in building and constructing the coastal reservoir. And then I try to compare about inland dam and coastal reservoir or coastal dam in connection with the Indonesian condition, because you know Indonesia is fire range and we have very high flood and so forth. And lastly, I would like to show you why the coastal reservoir so important and now constructed in a lot of the world in many countries and closing remark. Next, please. Ladies and gentlemen, we know the condition of the water resources in the world like this one. The red one, this one, it is very critical, the water availability and the waters. 2/3 of the watch right now in the stress condition to water supply. It means they attract the water resource about the same what they require. So it is very, very critical. Next, please. Another problem, most of the people in the world move to the coastal area. If you can see from the North America and the South America, most people, the rich people, stay along the coastal area. This one, and this one. Also, in Europe, especially in UK, including in Netherlands, in South Africa, and also in India. This is also in Cairo, you know, in Cairo only one Nile River, only one river in this country. So the people stay in the coastal area, which is very interesting for them. Also in East Asia, and including in Indonesia, especially in the north coast of Java. I will talk a lot about this area to see how we need to construct the coastal reservoir. Next, please. Hello. Contrary, where we live is different with where the water resources are available. We construct inland. We construct inland dam is different with where the water is required by the people. You can see this one. In the midland, in the highland area, a lot of them constructed. Also here, in Africa, you know, Aswan Dam is constructed in this area because Nile River is cross 7 countries. And the people stay in the area, in the coastal area. In Indonesia, more or less the same. Most of the dam, like Cirata, like Saguling, like Jatiluhur, Jati Gede, and so forth, is constructed in the highland. But the people didn't live there. The people stay in the long coast of Java. So, the problem is we need long distance of delivery of water, we need long pipeline and so forth. It is not effective. And in this area, earthquake also is very, very dangerous for the safety of the dam. Next, please. How about the water resources in Indonesia? There is 3 item that is a paradox for Indonesia. Indonesia is a country with high raining season. We have 3,000 until 4,000 millimeter per second. Compared with Europe, only about 1,500 millimeter per second. It's far away, maybe 3 times of their capacity. But at the same time, in the drought season, there is no water at all. So we have to make it balance between the wet season and the dry season. You know, this Indonesia face critical water security paradox to achieve golden vision 2025. So we have to think about water. It is not always available, but it is a constraint in developing Indonesia. Second, despite possessing 6% of fresh water, Indonesia have 6% of the fresh water, but you know, 60% of the population only stay in Java, and the water available in Java only 10% of the water in Indonesia. Imagine 60% of the population stay in Java Island, but only 10% of water all available there. And it will affect to the growth of Indonesia economic. Next please. I like to focus on the north coast of Java. The first, we have a problem with high population growth and urbanization. The second, insufficient fresh water resources, as I explained before. The third, land subsidence. You know, from Jakarta into Pekalongan, Demak, and so forth. The land subsidence is between 7 till 12 millimeter per year. Imagine only during 15 years, the land subsidence will be about 1 meter. It is so dangerous. And then the fourth is about the availability of land is very limited and the price is very high. So it is very difficult if we want to develop any more inland reservoir. And also, high rates of drought, and lastly, along the coastal is very vulnerable of flooding. Next, please. Let's see our national commitment. You know that the north coast of Java contribute about 40% of the revenue of Indonesia, and about 70 million people settle along of the north of Java. It is very big one. So we have to save this area. We have to save from any flooding, land subsidence, short of water resources, and others. But the three one is very, very important, and we have to recognize well about that problem. Okay. Then, next please. This is just a sample for Jakarta. This is area of land subsidence and so forth. Is very, very, very dangerous if we fail to protect that area. Next please. Next please. I just want to concentrate about this water from the 8th Astacita. I just want to talk about this one. Really, we have to secure about food, energy, and water. In this case, I just want to talk about water security. Next, please.
No.
You know, right now, Indonesia plan to construct speed wall, sea wall, river protection, and so forth from Banten until near to Surabaya. It is, of course, we realize it is very, very costly, but we have to do that because it is very, very dangerous one of the tidal flooding of the land subsidence and so forth. So this is one of the problem that we have to execute. And we have to prepare, we have to make available of water in this area too. Next please. You know, this is the water crisis. Residential, we need this one. Industry, we need this one. And also the land subsidence and flooding. Only this area, I will try to explain in more detail. Next, please. Next, please. You know, this is one of the concepts, you know, about giant seawall and reservoir, coastal reservoir is really one package. Because if we develop that area, we have to prepare the water availability to that area to develop. So this is just example. I know there have been about 27 concepts how to develop that giant seawall and reservoir. I just take one of them. This is we try to propose this development from Cisadane to Bapenas, how to make the coastal reservoir. If this system established, so the problem of for Jakarta will be finished, because that capacity is about 35,000 liters per second. It is very big enough. If we want to develop that, then it is a part of giant seawall processes. Also, the other area in Marunda, we have to develop simultaneously about water resource and protection. Next, please. Next, please. Next, please. Goes under 20 minutes. So this is, what is a coastal reservoir? This is by definition. Yeah. It is, should be, there is a dam, sluice gate, spillway, and so forth. I will not inform in detail how to calculate, but it is just a component needed to construct coastal reservoir. Next, please. There is two concepts of coastal reservoir. The first, we call it first generation. First generation means that reservoir is constructed in the estuary of the river. It is first generation. And then the second generation, the reservoir constructed offshore, goes to the sea. So this is the second generation. It is the first. Indonesia have experience to construct the first generation. I will tell you later. Okay?
I'm sorry, Professor, to bother you because there is a technical issue and also the Professor Nishikawa have to leave the Zoom meeting. Is it okay to divide the presentation after Nishikawa, Prof, to continue?
Okay.
I'm so sorry.
Okay, thank you.
Okay, because Mr. Nishikawa already in the Zoom meeting and he will continue to another occasion. I'm so sorry, Prof, to bother your presentation. And Professor Nishikawa, have you hear us?
Hi, good
It's
morning.
clear
Can you
enough?
hear me?
Okay,
Can you hear me?
we can apologize for the technical issue, Prof. Maybe to sort the presentation, could you please to share screen your
Okay.
presentation first?
So now you mean now you can hear me?
Yeah. We are clearly.
Okay.
Yeah, your voice is clear.
Okay.
Great.
Now I'm sharing my screen.
Yeah, you can share screen first.
Okay, thank you very
while
much.
you share
Thank you
screen,
very
maybe
much.
I will introduce Professor Nishikawa. Is widely known for his contribution in advanced sensing and monitoring techniques for bridge and civil structure. And also his work continues to influence sustainable construction practices across Asia. Okay?
Okay, thank you very much for
Okay.
the introduction. And also, I'm so sorry, Professor Doctor Yamato Tenno, to interrupt the presentation. I'm so sorry.
Okay, Prof. Nishikawa, the screen is yours. You have 20
Okay.
minutes for presentation.
Okay, thank you. But unfortunately, actually, I cannot talk for 20 minutes because of my scheduled business trip. So I would like to summarize the topic, the presentation today. Okay, so once again, first of all, thank you very much for giving me this opportunity to deliver today's keynote speech. I wish I could attend in person, but due to my schedule, I'm joining online today. Okay, so today's my topic is bridge monitoring in maintenance and management. This is outline of my presentation today. I prepared, but unfortunately, I may skip the introduction to move on the bridge monitoring. Okay, can you hear me?
Oh, yeah.
Okay. So I think I should skip the introduction part. I organized some the important matters related to the bridge maintenance and the asset management into the introduction section. But I should skip this one due to the time constraint, so that I will move on directly to the second part, bridge monitoring in bridge maintenance management and also the bridge asset management. Okay, so let me skip these slides. In this slide, I organize some the crucial the matters related to the maintenance management and also the asset management. So if you are interested in these fields, please refer the handouts I provided you in advance. I'm so sorry, but let me just skip the introduction part today. Okay, so from here, I would like to move on the topic of the bridge monitoring in BMM, bridge maintenance and management, and also the BAM, bridge asset management. So these some slides, they presents the fundamentals and also the key points on the bridge maintenance, the monitoring. Not only the bridge, but also the other kind of the structure monitoring. Okay. As you know, the monitoring is some of the set of the activities on the observation, the measurement, inspection, diagnosis, in order to grasp the state of the object continuously in time, over time. Okay. Observation is to observe or measure the changes in the phenomenon with the predetermined scale, like a unit. And the measurement is to keep a track of the quantities for the purpose, some of the certain purpose. And the analysis, this is a process to measure, to analyze the data, the measured data, or obtain through the measurement and observation, to extract some desired information, some of the information needs. And the judgment is to determine the condition of the structure based on the results of some of the previous activities, the procedures like observation, the measurement, and the analysis. Okay. So with the recent technological the advancement, the measurement can now be performed more easily and at much the higher level, the higher the process, the level than ever before. However, it still cannot be said that the analysis and the judgment have become easier. So that the analysis and judgment are still the challenges for us. Okay. And there are several objectives of the structure monitoring. So that it is to continuously monitor the structure performance and the safety. So mainly, or generally speaking, there are here that I showed the 5 objectives. The assistance with the decision making in abnormal events such as natural disasters, and understanding the changes in structure performance over time. The verifying the design performance of the target objective, the bridges and the structures, and to ensure the safety during the construction, and they assess the roles and the responses, not only the service life or service period, but also the design and the construction, the phase. Okay, and from here, the several there are these slides. I showed some of the more details in those the objectives. So please refer them later. Let me skip today here, and also the measurement analysis and the judgment. Okay, so that these the key points for the measurement, analysis, and the evaluation are also listed here, and also you can find the furthermore the detail in the slides in appendix. So please refer to the handout them later due to the time constraint. Okay. So with the remaining time, I would like to introduce a few actual examples of the bridge modeling. So the first one is the bridge monitoring in maintenance, especially for the short term, the decision making. Okay. So the many of the bridges in Nagasaki, the place I'm here, are located close to the coastline, and there are large-scale bridges connecting a lot of the islands and the peninsulas. So as a result, they are exposed to the severe the environment, and so that's why they have been facing some of the complex structural problems on the bridges. So in those cases, Nagasaki Prefecture government consults us, Nagasaki University, about managing those cases if it is a difficult situation on the bridges. And then once they consulted us, the university, we conduct the investigation, measurement, analysis, and R&D, research and development as necessary. Okay, and this case is one of them, the long-term remote monitoring of a steel truss bridge, in order to comprehensively investigate the cause of a critical crack occurred on the truss bridge, this one. So in this case, the huge, the wide, large, and long crack occur at the bottom part of the diagonal member of this truss bridge. So once the administrator found this case, they urgently conducted the investigation and the temporary repairs, and as well as the transport traffic restrictions. Okay. And in parallel with lifting the traffic restrictions, the permanent countermeasures are carried out. Okay. However, since the cause of the crack has not been clarified, so there remain a risk of the similar damage occurring because the truss bridge has so many similar members as the damaged member. Okay. So therefore, through the investigation was conducted to determine the cause by the long-term monitoring, and then based on the findings obtained through the long-term monitoring, the government, Nagasaki Prefecture government, conducted the preventive measures. So let me skip here. In this slide, how this bridge fell from the Nagasaki University are shown here. So based on the survey and also the consideration to the environmental condition and the traffic condition, we targeted the wind-induced vibration to identify the phenomena. That means the dynamic behavior of the bridge against the wind condition. Okay. So we installed so many the sensors, accelerometers, and the strain gauges, and also to identify the wind condition, we placed the anemometers, windmill anemometers, and also the ultrasonic anemometers to examine the complicated the wind flow, the air, the behavior. And we developed a measurement system to organize, manage so much amount of the data obtained through the long-term monitoring. Okay. So the bridge side was connected to the university via the internet, and I mean the mobile, the communication, the network. So the system they provide us allow us to manage the sensing system online, and also the securing the data online. Sorry. Okay. So we found the two kinds of the bridge, the dynamic behavior of the target, the members of the bridge. Under the two kinds of the two wind condition. The first one is a higher speed, the wind, stronger wind, and the second one is a moderate wind. Okay. So we identify and we observed, we confirmed the occurrence of the dynamic behavior of the target bridge under the wind condition, that we estimated the cause of the damage. And we concluded that the cause of the damage was a fatigue damage induced by the wind-induced vibration. Okay. And based on the findings, the Nagasaki Prefecture government conducted the preventive measures by connecting the diagonal member with the vertical members by the PCE, the cables, to tie up, to shift, to change the dominant frequency of the target member. Okay. And after the preventive measures, we confirmed the effect of the measures by conducting some tests in situ. So we confirmed that the dominant frequency shifted to the higher range. So that in this condition, there is a very rare, the risk of the reoccurrence of the damage and also the rated the behavior, the phenomenon are mitigated. Okay, so these are the summary of this case. So please report this later. And let me move on the second case, the application. This is bridge monitoring for asset management, especially for long-term policy making. Because as you know, to assess the bridge condition, the objectively, we should have some of the index or some of the categorization or the indicator. And in the Japan case, we have a soundness the indicator from 1 to 4. Okay, so the stage 1, this is a sound stage, and the stage 4, this is urgent rehabilitation stage, and the 2 and 3, these are the preventive maintenance stage and the early rehabilitation stage. Okay, so according to these, the categorization or the condition assessment, the bridge owner should do something to maintain and manage the bridges in Japan. Okay. Okay, and so we have, generally speaking, 3 kinds of the strategy for the maintenance and the management. So it is common practice to express the thresholds for structural condition or the deterioration level. So this diagram, this slide, schematically illustrates the progression of the structural condition under 3 maintenance policies: preventive maintenance, the rehabilitation, and the replacement. Okay, or the corrective maintenance. Okay, so in preventive maintenance, the serviceability, the threshold is defined, and the intervention are this one. And the intervention are implemented once the condition falls below the threshold, acceptable limit, or the serviceability, the acceptable limit. Okay. So this process is repeated to maintain the asset above the target level. That means that the sound level. Okay. So this approach characterizes the preventive maintenance. And when comparing these, the rehabilitation is to restore the structural integrity of the bridge and the correct major safety defects. So the rehabilitation intends to improve the rating from poor to fair or poor to good. Okay. And the replacement is to replace the entire bridge or component level or the element level, and as well as the associated approach work. So the replacement option, the concept intends to improve the condition of the total bridge element from poor to good. Okay. So when comparing the policies, the vertical allows this one and this one corresponds to the amount of the required the cost or the resources for intervention. So these include the economic resource, technical resource, human resource, and the time-related resources. Okay. Okay. Then we have several kinds of the grading and prediction, the manner or the ways. So this is one of the most simple one. This is a time-dependent deterioration model. Okay. So the structural soundness can be modeled as these kind of the curves over time. And so once we defined the mathematical model to grade and predict the structural soundness in future or over time, we can predict the condition in future. Okay. And this one is another case, another method, the Markov chain model. So some of you may know this one. This is a little bit the complicated one, but anyway, by utilizing this model, the method or this model, the structural soundness can be also the predicted, the forecast like this. Okay. And then utilizing these, the manners, the method, the Nagasaki Prefecture government, the forecast, they predict the structural soundness at each component level like this. And they set the criterion of the soundness for repair judgment. So that based on this, the simulation, they can simulate the structural soundness in future and also estimate the cost. Okay. Yeah. Okay. So this is this is not some of the conventional bridge monitoring, but we can say this is one of the representative example of the monitoring in road asset management, especially for the long term the decision making or policy making. Okay, so I'm sorry, due to the time constraint, I cannot catch the share all of the matters in detail, but I hope this will serve the hint and idea for your active discussion among all of you. This is it for today. Thank you very much.
Okay, thank you very much, Professor Nishikawa, for the insightful and comprehensive presentation. Because of the limited time for Professor Nishikawa, I would like to summarize from the Professor Nishikawa presentation. There are the key points how we need to have the structural monitoring observation, measurement, inspection, and diagnosis. And bridge monitoring maintenance can also have the strategy to manage how the bridge can have the more lifetime for the structure. Thank you so much, Professor Nishikawa, and we are apologize because we have so technical issue, and maybe if you have any equation, you can leave the Zoom meeting. Thank you so much, and maybe have a warm appreciation for the Professor Nishikawa.
Okay, thank you very much. Thank you very much for everyone.
Okay,
and,
thank you so much, Professor.
Okay, and once again, I'm so sorry. The doctor, the intimated.
Okay,
Thank you very much.
okay, you can continue your equation. Thank you so much, Professor. Okay, to continue this discussion, we will continue from Professor Indratmo. We kindly apologize for the delay presentation, and to continue this event, please, Professor Indratmo can continue for the next slide.
Okay. Tell me the time available for
The
me.
time remaining still 20 minutes. It's okay for you, Professor. Because we will gather the Q&A session, because Professor Nishikawa cannot gather the Q&A session.
Okay, thank you very much.
Sorry. Thank you.
I will continue my presentation. This is just the concept. The first generation of coastal reservoir is just using estuary of the river. And then the second generation, what's developed right now in many countries, is in this one. Well, for the second generation, Indonesia don't have such a kind of second generation, but we have about 4 coastal reservoir with the first generation. Okay, next. It is not necessary that what we have is until fresh water, but depend on the requirement what we want. It is also possible using this system for the fresh water and the dissolved water and Smith for certain purposes. Okay, next please. we have, Indonesia have experienced how long desalination take place for the coastal reservoir. For example, when we construct the coastal reservoir in Batam Island, we need about 14 months to desalinate water until it can be used for the water supply. So it takes time. So based on our experience, it is very, very careful in cleaning the reservoir before we store the water inside. So the saline water should be taken out before we fill with the fresh water. Also about the spillway, at least we have to consider 4 items. We have to know about the tidal rates. The second, we have to know the wave heights. And then the third, we have to know the run-up of the water. And then we have to decide about freeboard. And then based on that, we can decide about the dam crash and the spillway crash. So the spillway crash maybe not depend on how much water we want to store, but it will be also depend on the heads of the water from the downstream from the sea. Okay, next please. I will give you some existing coastal reservoir in the world. Of course, one of the old one is from Netherlands. I think our guests can talk in more, because you know in Netherlands in 1953 there is a very big flood, almost to 96% deaths in this time. So it makes the Netherlands very worried, and they construct about 4 big dams for protecting them from the flood. And also in India, this is for agriculture. In South Korea, Samangun, this is one problem of Samangun. It is about water quality. I have been there and I observed the problem is the distribution of the water is not as imagined. So the quality is okay, but the quality will be problem. So it is also one of the lessons if we want to develop the first generation of the coastal reservoir is correlated with the water quality. Also in Hong Kong, China, and the most popular maybe in Singapore. You know, up to now, Singapore is very dependent on Malaysia to have fresh water. So right now, they develop their own about coastal reservoir, and now they are independent, and they have protected from the floods, and then they got fresh water. You're applying what we call coastal reservoir. And United Kingdom, and also we have Duriangkang, we have Tambesi, we have Nusa Dua, and I think that's 4 already constructed by Indonesia, but we have many in North Java, but it is not coastal dam, but it is just barrier. It is like weir made of rubber dam. Okay, next please. This is just example of the structure using for coastal reservoir. This is soft dam. It is made of rubber. It is a very practical one. I know it is very practical one, and the size, it is possible under about 6 meters of the diameter. It is still safe enough. And then this one and the structure, we can combine with 2 catchment area together. We can let out the quality of the water and so forth. So we can link it about the pipeline and water gate for overflow of the exits of the water. Okay, next please. This one in North Korea, and this one what I talked about, it is the longest one in the world, in South Korea. And Marina, it is in Singapore. I will show you. Next, please. And this is an example of in Singapore, it's a very popular one, Marina Barrage. Okay, let's please. And it is so interesting because it is not only how to store the water, but also for tourism and for ecology, ecosystem, and so forth. And they use very big pumping system. One pumping system is about 40 cubic meter per second. It is one of the biggest pumping system in the world because right now the biggest pumping system in the world is only 60 cubic meter per second. It is the biggest one in the world. So imagine one of the largest pumping system in Jakarta is about 40 cubic meter per second. It is the biggest one in Sentiong in Jakarta. So the size is very big one. Okay, next please. The Semangon, I told you, this is the length is 33 kilometer. It is the longest man-made dikes in the world right now. But initially, this will be developed for agriculture, but they changed the idea to be industrial area because if it is for agriculture, and then they have a problem how to manage that structure, the income is low, so they try to change the aim of that of the construction. But they have a problem of the quality of the water in this area. Okay, next please. I think you have explained. I have been there. I quite long time in Amsterdam, in Delft. I imagine how difficulty at that time with the technology available, but it is very exciting. I just imagine at that time it must be need a lot of money. So it must be need a lot of money. It is similar when Egypt construct Aswan. It will be almost bankrupt. That country. Yeah. Okay. Next, please. I would like to tell you about some consideration in constructing the coastal reservoir. First, dam or seawall, it is the most important element in coastal reservoir. So, the water from the sea cannot spill over. Also, the water from the reservoir cannot spill over in the dam. But we have to calculate carefully about the elevation of spillway, elevation of dam. It is different how to calculate compare with inland reservoir. It is completely different. And then there are many ways. There are many material use. There are many construction methods depend on the technology available. So the selection of type of dam or seawall will affect the construction and maintenance. So the capital and the operation and maintenance should be carefully calculated. So we have to optimize the structure. We have to know the availability of material. We have to know the quality of manpower and so forth. It should be included at the beginning during constructing the coastal reservoir. I tell you again about the technology availability and the two other things, social aspect and environment. Of course, compared with inland dam, social aspect is much less compared with inland dam. So why coastal reservoir is very interesting and it is considered cheaper and less risk compared with constructing the inland reservoir. Social and environmental effect also be considered, but it is not as big effect compared with inland dam. Okay, next please. Type of coastal protective structure you can use earth fill, dike, or water. Masonry concrete, it is conventional one. You can use this. You can use steel sheet pile, but be careful because the saline water is very corrosive. So you have to be careful using material because acid water or saline water will be affect very much to the material. You can use geotechnic. It is one of the most popular one because quite cheap and the availability of material is very high in Indonesia. Steel sheet, the third is quite expensive, and this one is safer and cheaper, fabricated okay, and sometimes we make combination between material with another material in connection where the structure will be constructed. Whether it is in the path of fresh water or this will be directly face to the sea water. Next please. Okay. The fifth, I want to compare between inland dam, their existence, versus earthquake because Indonesia have risk, very high risk of the quake. Every day there is no time without earthquake in Indonesia. Sometimes 100 of earthquake in one day. The problem is only about magnitude, but it is very risk. So why the return period of constructing them use return period of 2,500? It shows that risk of earthquake is very high in Indonesia. Dams are often built in seismically active areas, such as Indonesia. Of course, along of the east part of Sumatra, in the south part of Java, and then go to the north to Sulawesi until to Philippines. It is very, very big condition which we want to face about seismic, and in short, it is area with very, very sensitive to the earthquake. The second, reservoir can trigger earthquake. Why? It's happened. Some water supply structure are vulnerable to seismic motion because in the inland dam, sometimes 100 meter or it may be more than that. So higher structure will have problem with earthquakes more sensitive. Contrary, with coastal dam, it is low structure, maybe only 6 meter. I think 10 meter is quite big enough. So it must be more severe compared with inland dam. And then second, unstable slope, of course, if the water level increase, it will makes the slope stability to be more sensitive. And then the consequence of water supply failure and other impact if failure happen, and then what happened with the people surrounding it of the structure. So, beside of the difficulty in obtaining inland for constructing the dam, also the risk of constructing inland dam is to be significant. Okay, next please.
3 minutes left, Professor.
Okay, I just want to show in the words. Indonesia have erosion very high. So the lifetime of reservoir is very short. Suppose you construct with 100 years return of period, or 600 years, but in fact, some of them only 50 years will be full. Suppose like we have what we call reservoir in Brantas, Sutami, its name. After calculating the sedimentation, it will finish in 2038, maybe only about 12 years later from now. So what we need, we want to make diversion channel, we want to take out the sediment, and it need, we calculate some time ago, we need about 8 trillion rupiah. So expensive. So if we construct okay, we have about 300 big dam inland. Up to now, we maintain about the sedimentation is very limited. So it's problem. And if we calculate about 1% or 0.8% in the Works dam, so in 2010, if there is no new dam construction, it will finish. So it must be considered by the government how to maintain the existence of the dam available right now. Okay, next please. This is some reason why the coastal reservoir construct right now. Growing freshwater scarcity, especially in the north part of coastal in Java, it is a real problem. So many industrial area built up in there, but there is no water available. So we need like di Jakarta, Semarang, Pekalongan, Tegal, Gresik, and so forth. We have to have that. Indonesia, we have 128 river basin authority. At least one authority have one big river. So there is a very big possibility to construct coastal reservoir. Big city in Indonesia, mostly just close to the mouth of the river. So the potential is very, very potential to construct it. Like Palembang, like Jakarta, Surabaya, Semarang, Makassar, Pontianak, and so forth. It is very potential one to construct it. It's because of growing freshwater scarcity. The second is about flood water, and we have to capture the rainfall. Next, please. Limited land for inland dam, especially in Java Island, is very dead, very populated. There is no space again to construct big dam. It is very costly to use the land open there. And then environmental ecosystem benefit compared with traditional. We can use that area for tourism, very close to the end user, and then we can use for solar energy and so forth, and also for multi-purpose infrastructure. Next, please.
1 minute, maybe, Professor.
Okay. Climate change, construction and operation cost. For the coastal, it will cheaper compare the inland. I will show you the comparison. Okay, next please. Here, I just want to show you that using coastal reservoir, capital cost per cubic is very cheap compared with other. Compare with wastewater reuse, compare with desalination plant, compare with inland dam. So, there is no reason for Indonesia not constructing coastal reservoir. It is much cheaper, safer, and close to end user. The only problem in Java about water quality, but it can be used for the leased land. If we want to construct coastal reservoir, we have to remind the people over there, we have to maintain the quality of the water in the river. Okay, next please. It's very cheap one compared with others. Also the running cost. Next please. As like example, okay, go. There is a problem in Netherlands, the area with saline water after closing to be fresh water. So some farmer complain because they lose their job because the water is changing from saline into fresh water. So I heard that some of the dam will be taken out. Next, please. This is in Indonesia. This is what's called Duriangkang, and then Rempang, and then Tambesi. You know, in Batam Island, no one can use groundwater. No one can use groundwater. So all that area, that industrial island should use only rainfall. There is no river anymore in there. So by using rainfall, they store, there is about 6 dam over there, they can fulfill the water for the industry. And I think Batam Island Authority in manage the water is one of the best in Indonesia. Okay, next please. This is Duriangkang. Yes. I mix this test. I did the physical test for constructing this in 1994 because we have to experience at all at that time. So we have to make a physical modeling, make sure that it is safe enough to construct. And okay, there's no problem. I did it only very short time, only 6 months to make sure that it is constructable. Okay, next please. Okay, next is just technical specification. Okay,
Maybe
next.
the time is up, Professor.
Yeah. Okay, next. 1 minute. 1 minute. Next is Tambisi. This is Rempang.
Okay.
And then next. It is in Bali. Next. Okay, next is Bali. It is proposal for Bapenas. If we want to make coastal reservoir in Cisadane, the problem of raw water for Jakarta finish. Okay, next please. It is remark, closing remark. This is just you can consider the comparison between them in there. Okay, thank you.
Okay, thank you so much, Prof. Indratmo. Give a warm applause for Professor Indratmo. Ladies and gentlemen, as scheduled, we will now proceed for our first Q&A session. This is an opportunity for the audience. Also, we have an audience professor in mini theater. Is that clear enough, our voice to the main theater? Okay, maybe if all the audience have the question, please state your name and the affiliation. For the Q&A, we will first Q&A, 3 questions, please. Okay, 1 and 2, maybe from the mini theater. 1 and 2, please help for the microphone. In the mini theater, is there any question? Okay, 1 from the mini theater. Okay, the first, please. The first question, please. Please state your name and from your affiliation.
Baik, izin dalam bahasa Indonesia ya Bu ya.
Oke.
Ya, terima kasih atas kesempatannya. Nama saya Asif dari Mertani, Jogja. Kebetulan diundang dalam pameran di lantai bawah. Dan ini saya merasa sangat relate dengan materi yang disampaikan. Karena kebetulan kami juga berkontribusi Pak dalam pemantauan tinggi muka air laut di Tanggul Jakarta dalam pemasangan AWLR di sana begitu. Nah, ini saya ingin bertanya satu poin begitu terkait maintenance coastal reservoir begitu. Nah, kalau kaitannya dengan melakukan maintenance, apakah ada permodelan tertentu Pak dengan memanfaatkan parameter seperti tinggi muka air, parameter cuaca dan sebagainya begitu agar maintenance-nya bisa berjalan dengan lebih baik dan tentunya bisa lebih panjang begitu usianya. Begitu, terima kasih Pak.
Maybe we continue to the second question first, Prof. Okay, the second question.
Okay, thank you for your time. And then, actually, my name is Devino. I'm from Implementation Unit of material and structural building that located in Chileni, as known as Puskim, Old Puskim, and refer to the presentation that Professor Indratmo presented before. I mentioned about the coastal reservoir. There are two kinds of the coastal reservoir. It's the first generation and second generation. And unfortunately, because of the limited time, you cannot explain it quite clearly. So I want to know more about the first generation and the second generation. Which one is more, how to say, priority to be built for the first time? Because, you know, as the public works employee, public works worker, we need to, separated the project for 1 year project, something like that. And then if we need to build the two generation of the building for the coastal reservoir, which one is preferred to be built for the first time and then so on? And maybe you can describe the reason why and stuff. Thank you very much.
Okay, when in the question, it's okay for another question? Okay. Okay, for the last question comes from Mini Theater. Hello, from Mini Theater. One question? Okay, maybe we will answer first the first and the second. The first is related about the maintenance for the coastal reservoir, and the second is the different from the first generation and the second.
Okay, after considering what exists right now, it can be seen that such first generation in Batam, it is a very cheap one compared with inland dam, because the coastal dam, it is only not high enough, It is not high enough, and then the quality of water, of course, it must be considered. Mostly, the quality of water in the coastal reservoir is not good enough compared with inland. But inland only a part of maintenance one. But the rest, it will be very cheap. It will be very cheap. You can obtain our
Presentation?
Yeah, presentation. I have compared, and we have discussed with others experts about the operation maintenance in terms of the money. It is cheaper. However, for the capital, it will be depend on the size. But if for the second generation, it will be cheaper compared with the estuary in terms of cubic meter in terms of cubic meter of water. Because second generation, we can store a lot of water, much more compared with estuary. So it will cheaper. However, it will also depends on the slope of the coastal area itself. If it is very mild, it will more expensive compare if it is steep enough. And also will depend on the condition of geological aspect. But if we learn from the Tembesi, Rempang, and then the other one in Batam, it is very, very manageable and can be seen how to calculate the maintenance. I prefer to say the maintenance should be connected per cubic meter of water contained in the reservoir. It is the first question. And then the second is?
Yeah, is the, we compare from the first generation, right, into the second generation. Which one is better to develop first?
Oh yeah, of course. If we have money, we have to develop the second generation, because we can store more water compared with estuary. And right now, most of the countries who develop coastal reservoir, only a few who develop in the estuary. They have developed more than that. So they develop for coastal reservoir offshore. So it will more consumable. We can use water with quality better compare if only in the estuary itself. So we can process it from the quality of water as it is, and then we try to use wetland area, and then we use another processes until the last one in the containing area, we can store more water, and finally it will cheaper compare with estuary. However, estuary still cheaper compared with inland dam.
Okay, thank you so much, Professor Indratmo, for the answer. And because we have a time limitation and also we still have the next speakers, I would like to highlight it about the urgency to develop the coastal reservoir in Indonesia, especially maybe in the central of Java. Thank you so much, Professor Indratmo, for insightful presentation. Maybe you may return to your seat and we can continue to the next session. Thank you, Prof. Okay, we move to the second phase. We will have 3 speakers from Netherlands, Japan, and Taiwan. Without any further ado, please come forward to the stage, Mr. Alwin Commander and Mr. Gan Buntara, our Professor Gan Buntara, and also Prof. G. Herchen for joint online presentation. Please have a warm applause. Sorry, Prof. Yes. You are in the center. Okay, the next session we have 3 speakers. Our third keynote speaker, we will have Mr. Alwin Commander from Royal Haskoning. Mr. Commander is the Business Development Director of South Asia at Royal Haskoning and specializing in climate resilience, river and coastal engineering, and sustainable water management. With over 12 years of experience across the Asia-Pacific region, he has led numerous strategic projects and flood risk management. His work focusing on helping cities, industry, and communities live safer and smarter with water in an area of growing climate change. Mr. Commander, the floor is yours.
Yeah, thank you.
Okay. You have, okay, we have a pointer.
I will arrange that.
For the pointer. Sorry. Thank you so much. Thank you.
Okay. Yeah, thank you. Do you have a presentation? Yeah, very good. So thank you very much for inviting me to the first international conference. Delighted to speak here today. I will not touch upon these very large infrastructures. I rather speak a bit about smaller infrastructures, but also in the coastal, river, and urban area. How do we go next? Okay. We are an industry player. So Haskoning is one of the largest and oldest engineering firms from the Netherlands. We cover 9 markets, but I will not bore you too much with my company. Maybe next slide. Nowadays we have presence all over the world, so we bring this Dutch knowledge, but also knowledge from Indonesia back to the Netherlands. We really try to exchange the information on engineering across the globe and help our clients to improve their infrastructure basically, or their assets. Next slide, please. So what I want to do is I want to talk a little bit about nature-based solutions and building with nature and nature-positive engineering. And the past, I think 15, 20 years, this has been a very hot potato. I thought it would be nice, because I'm about a decade now in Southeast Asia, just to show a collection of things that actually materialized and what did we learn, and should we actually continue doing it or not. So the first was about 10 years ago when I worked this is the 7th largest river in the world, the Irrawaddy, next to the city of Mandalay, about 1 million people, and they're very dependent on their port. But once in every so many years, the river basically swaps from this main tributary to the other one, because you have very heavy flooding season, and that changes the entire river. I'm not sure whether you can reanimate the one on the right, but this is a very dynamic thing. And our client and the World Bank asked us, how can we prevent this from happening, and how do we keep the port of Mandalay accessible? Next slide, please. Now, with all nature-based solutions, it's all about creating an understanding. An understanding of your physical system is very important. So here we analyzed how is this shift happening. Next slide, please. And of course, nowadays we have very advanced numerical tools. Maybe you can animate the video. So we can reflect what happened the past 10, 20, 30 years in the river with advanced numerical tools, and also put some interventions into it and predict what happens. I don't think we have a video, but you have to trust me that it moves and that it's quite state of the art. Again, next slide, please. So what we came up with, so this is a period of a year in which we do a feasibility study and all the assessments, is why don't you grab a bit of sand from the main channel and dump it continuously in that little channel. So you create a kind of a push, and you avoid the river to go into that little channel once in a while. So you would need a small pump or a small dredger like this. In the Netherlands, this is considered innovative sediment management dredging. Next slide, please. But what our client said in Myanmar, I don't want a boat that dredges all the way around the river all the time for years. The people will think, I'm not managing anything, I'm still building, right? I want to build something big. I want to have Eiffel Tower size construction. So then we rendered some solutions for that. So this is a dike of 12 meter high, 6 kilometer wide, very difficult to construct, very costly, and also geotechnically challenge. Of course, this is a process together with the people living there and our clients. So next slide, please. So what we came up with was porcupines. Not the animal, but it's about the spikes, because you still want to create this kind of roughness in the system. So next slide, please. And this is what it looks like in practice. So it's a very simple concrete construction consisting of 6 beams of about 2 meters long. And we created 25,000 of these and put them in the field. They're very easy to maintain, they're very easy to construct. And actually, it's not an innovation, it's just an old idea from Bangladesh, where they use it in the Brahmaputra with bamboo sticks. So you see that here. We just upgraded it, and with all the physical understanding and the modeling and the field tests, we kind of improved the concept. So next slide. So this is what it looks like. Next slide, please. And this is what you see after one season. So after one season, 2 meters of sand accumulated about 60% of these porcupine fields in this small tributary and pushing back the main river. So here we did some other studies together with the Delft University of Technology. And the thing is, if these things are broken, they're very easy to repair or to replace. Next slide, please. Now, first takeaway. You don't have to reinvent the wheel. Just look at what you already have and try to upgrade it. Next takeaway, infrastructure can be small. And I'm not suggesting the porcupines, but the dredging alternative was actually quite nice. It doesn't have to be that big to be impressive, right? So think outside of the box. Okay, now next slide. Another example that is being constructed is in the Manila Bay. So here, very similar to Semarang, Demak, Jakarta, we have a lot of issues with erosion. Every year typhoons hit, huge waves. This is a challenge. Infrastructure becomes quickly very expensive. So since 2020, we did a strategy for the Manila Bay, and we developed a number of approaches and infrastructural projects, of which we selected one to be actually built as a start. So again, this is already a 5-year plus journey before things are actually happening. Next slide, please. So this is the concept. It's about 1.5 meter, 3 meter deep. But because of the waves, we need some kind of protection in terms of hard material, so rocky material, breakwater. At shallower areas where the waves are milder, we can use bamboo breakwaters that can maybe last for a couple of years and then decay. And here in the back, this is a concept that was also tried out in the muck, not that successful, but it's still being tried. But here it seems to work quite well. So we create these kind of bamboo fences, trap sediments, and let mangroves grow again. So the idea is that over time, these fences are gone, but the mangrove lasts to protect the shore with the natural mangrove buffer. And in the back, we have some sustainable agriculture, aquaculture going on. So it's currently being built. As you know, past weeks, there were quite a number of typhoons hitting, and it's difficult to predict with our models and with our field tests whether it will actually survive. So there has been some damage, but it can be restored. Next slide, please. This is from another angle, a bit fuzzy. But the nice thing about this solution is that it's not only protecting your coast, but because of the mangroves and the oysters that can grow on the breakwater, you create some extra livelihood, some extra economic activities for the village, basically. So item number 3, takeaway. We don't know everything. And by building these things, we can monitor, measure in the field how these things perform, and learn and share that information across the globe. So a part of this project is to have this monitoring campaign, see how the coastal defense is working. The fourth is, if you understand what the community needs in terms of aquaculture, in terms of their livelihoods, you can build way better multifunctional infrastructure. So working together with the local community becomes more and more important for our infrastructure, basically. Next slide. Now, I lived in Ho Chi Minh City in Vietnam for a while. This is a picture not unfamiliar in the rainy season. I think similar as Jakarta at some places, similar as some Semarang places. So there is this district called Tuduk. It's about 1.5 million people, and a large part has already been built up. And the People Committee of Ho Chi Minh asked us, how can we improve this flood situation? So next slide. So what you see here, the red areas are actually areas where there's no space to retain your water. Everything is built, asphalt, houses, factories, etc. Well, here on the right we have a more wetland kind of open agricultural area with a lot of opportunity still. So of course we chose the most challenging area, P1, to investigate further. And again, here we use numerical modeling and all kinds of computer models to calculate what would happen in a flood event and what also would happen with climate change. Next slide, please. So this is the current situation. Basically it rains and then it needs to drain to the river. Next slide. Now in the future we would expect sea level rise. So that means you need to start to protect yourself. You would expect more rain. And you would also expect more build-up areas. So you see the problem, it creates itself basically. You create more flooding if you don't manage this well. So next slide. So the alternative is somehow protect yourself, but somehow also do something with this drainage system. Perhaps you can infiltrate or delay a part of the water. Perhaps you can store it in your city for a time that you can discharge it again. I think this is a very familiar concept for people working in the urban space. Next slide, please. So here is where we put that on Ho Chi Minh City. So there's the delay, store, drain, and protect schemes. And the idea is to also look at the biodiversity as much as there still is. How can we connect these green patches across the city and improve the flood situation? Next slide, please. So the green box is a major statement. Most of the investment that the World Bank will be doing, about $300 million, will be about upgrading drainage, so gray infrastructure. It's inevitable. We must do that. But another part is about green-blue infrastructure, and that's what I want to show you. Next slide, please. So this is, that cross-section, and then some opportunities that you could do, like a natural wetland park, like a blue-green building, etc., etc. Next slide, please. So to protect yourself, you can build a simple dike, or you can make something multifunctional, where the people can do some running, where the people can do enjoy a bit of nature with wetlands. These are relatively inexpensive features that would really enhance your infrastructure throughout the city. Next slide. Similar area, another concept. Next slide, please. And this is nice. This is an urban wetland that we have designed, which fills itself, if you go to the next slide, during rainy season. So in the dry season, you can use it. You can go with your kids to the park. Well, in the wet season, it's inaccessible. It's mostly flooded. Similar idea here. Oh, yeah, next. Next. So just to prove that it does work, if we don't take action, we get flood risk like this. If we do take action with the investment, we reduce flood risk significantly. And this is the justification for $400 million investment. Next slide, please. So takeaway number 5, because this is actually being designed and it will go to construction next year. So it is possible to, in existing areas, to do these kind of things. But what we did see, because also the People Committee in Vietnam changed a number of times, you need a few advocates within the ministry that really think that this is a good idea and make it happen. And 6, spatial integration with whatever you do. More and more it becomes important that you work closely with spatial planning, with the planning department. And more for these kind of solutions, we get immediate issues with resettlement. People are living in the wrong place, basically, if you look at it from a natural perspective. So you need to manage that very well. Next slide. This is the last slide. This is from Singapore. So in Singapore, we work with the Public Utility Board managing the water and the coasts. So we do 2 very big coastal adaptation plans for this client. And also here we try to create these multifunctional coastal defenses. But the question is, why would we put more money into something that's more expensive while you can also build just a simple dike or drain? So this is what this last example is about. Next slide. So you want to create some kind of coastal defense, but if you think a little bit more carefully, work with the architects, work with the community, you can come up with things that are adding value to the city. The question is, how do we capture that value? So next slide. So what we did, we interviewed about 1,200 residents in Singapore, and this was really part of the study to justify these investments, to see how much are you willing to pay if you have a nice beach instead of just a dike, or if you have something aesthetic that makes your life maybe more attractive or more exciting in the city. Next slide, please. So these are the numbers, and this is a bit theoretical, but our economists, they know what to do with it. So what you see is that people are willing to pay $7 per point to prevent the loss, and they're only willing to pay 40 cents to pay an increase, basically. So that's very interesting. Similar with accessibility, people are willing to pay, over 20 years' time, about $90. So you can take this into account, but we need to do more studies to make the economic and financial feasibility for these things work. So next slide. Oh, you skipped, I think, a few? Okay. Yeah, indeed. So it's all about those co-benefits. Of course, the first major benefit is to reduce flood reduction. But then it's about what is the value of nature in your city? What is the value of recreation? You need to take that into account for this project to convince everyone that it's a good idea. So this needs more support and more study. And you also need to do it for Indonesia, I think, to justify the case. Next slide. So there's a bit of a closing remark. As a company, but also as the Netherlands, we do quite a lot of work here in Semarang, all across Indonesia actually, but I wanted to highlight Semarang here. These are projects that are designed and will go forward in the coming years. But next slide, we also have an exciting new project for the coming 2 years, which is about the Babon watershed and the Lok, and potentially also a project around the Mak to reinvestigate that. By saying this, I'm inviting all of you, because it's an integrated process, to come and share your ideas when we implement this project, because together we can make these things better and more suitable. All right, thank you very much.
Okay, thank you very much, Mr. Commander, for the inspiring presentation and also for sharing a global best practice that can guide the future sustainable construction initiative. Maybe before we continue for the fourth speaker, I would like to say hello first for Professor Gio Chen in the online. Have you joined with us, Professor Chen?
Oh, yes, I'm here.
Okay, just be seated and be patient because we still have fourth keynote speaker and then we move to the fifth speaker. Thank you, Professor.
No problem, take your time.
Okay. Okay, for the fourth speaker, we will have Professor Gan Buntara Stanley. Professor Buntara Stanley is a full professor of structural engineering at Nihon University, Japan, and specializing in numerical modeling, structural dynamic and seismic engineering. Educated at ITB and the University of Tokyo, he has authored multiple international books and over 100 scientific publications advancing computational and seismic resilient structural design. His work continues to shape global discussion on disaster resilient and sustainable infrastructure. Without further ado, please welcome Professor Gan. The time is yours. You will have 25 minutes for presentation.
25. Okay, thank you very much, ladies and gentlemen. So,
slide, please.
Okay, thank you for the introductions. My name is Buntara, so I'm Indonesian. So if you can ask using Indonesian language if you wish. At the end of the presentation, if you don't understand some of the terms that you're not familiar with. So today I'm going to talk about the bridging vision and reality through quantitative intensity frameworks. So this is a big project of mine, I make a frameworks based on this terminology. I will talk about this SIL, we call it SEAL, and we feel. This is for wind engineering. SEAL is for seismic engineering, for earthquake. And then FPIL for fire protection engineering. I hope this is a big framework. I'll get the outlines of the topics, each of the topics. And this is very useful for disaster resilient and sustainable infrastructures. Okay, next. Okay, these are my related works. I have been doing this started from 2019. It started from, there was a small company doing foundation using pile. And then this company asked me whether I can make a program to show the performance of the pile. So that, but it has to be quantitative. It's not just, you cannot just telling it's just a seismic strength design. No, it's not enough. Then we have to come up with numbers. So that's why we go from, we goes to this up to today. We make it quantitative to measure the seismic performance. Okay, next. Okay, this is the conventional seismic design. Actually, we have buildings, and these buildings has been subjected by many thousands or many hundreds of earthquakes, seismic ground motions, and then they made the design spectra, and then I think this we learn in the university's level, and then we apply the strength materials, concrete or steel, whatever, and then you can. This is a little bit research topics. Then you can calculate how the buildings fail. And then this is the diagnostic in a real situation when people see, oh, your building has some cracks, so it has to be strengthened. So this is the current conditions of our design. Then we need to improve this because this design codes is only static. Actually, all these response spectra also, and these results are static strength, safety design. Okay, next. I'm going to go fast because my slide is 36. The left side, on the left side is statistic data of human injured during the earthquakes in Japan. Okay? If you see the red one is when human died due to earthquake. So if you see along with the course of time, the standards has been revised. Every time the bigger earthquake comes and the seismic standard is designed again, then the structure become very strong, very stiff. Then what happens if the structure inside the building, humans are being shaken very, very strong also. That's why many people injured, not because the building failed, but because the shaking. Okay, then I come up with if it's strong, but it's still shaking. So this is the problem with the seismic strength building. So we have the problem with shaking that nobody care about because most of the designer only just designing a very, very strong structure due to against the earthquake. And then here is, maybe it's not so clear. I show you these two kind of earthquake in Japan. Maybe only different in three months in a year. In 2003, there are two earthquakes with magnitude of 7 and 8. And then the left side is we have about 1,100 Gel. Gel is a centimeter per square second square. And then this is the magnitude 8. So they have different magnitude. But they have the same shaking. Then what I want to say here is the acceleration is not so important, because acceleration doesn't means that it will destroy your building. Acceleration has to be combined with the frequency of the earthquake. So if you see this is very dense and this is very not so dense, but it has the same effect of shaking. It's about 5.6. And this is only 1/3 of the acceleration. from both to 1/3 acceleration. Okay, on the left down there, there are the hot scales. You know, if you eat chili or pepper, very hot, there are numbers to measure the hotness. And hotness, I don't know, is good English or not, but it's hot scale. There are numbers, and in Japan now they are using numbers also to measure the sweetness. How sweet is your orange? How sweet is your melon? So there are numbers. Of course, the more sweet your fruit is, more expensive. And these numbers I got from an idea from the Japan Meteorological Agency. You know, the early warning of Japan. Whenever there is an earthquake, you can see your TV is full of color with these numbers. These numbers is educated since they are in the primary school. So every student already know these numbers. 1, 2, 3, 4, 5 until 7. So if 5 or 6 is also already big. And these numbers can be calculated only in Japan. But these numbers are not included in the design codes. That's why I get this all together between these numbers with the structural analysis in design buildings. And then I combine this. Then we can give some numbers to your building floor. So this has to be customized with your building. And you'll get label on the top floor. You get the number of 6. And then I use these numbers to measure the shaking. So it's different building, although they are the same seismic strength building, but they have different kind of shaking, different numbers of shaking. On these numbers can differ your buildings. And after this, I will show you the application of these numbers. And then because we don't use magnitudo is just the magnitude of the earthquake. It doesn't mean that it will hit your building. It depends on the distance to your building, depends on the depthness of the source of the earthquake. So it means nothing for structural engineer. I'm so sorry for geologists. Geologists is very interested in magnitudo because they are interested in the magnitude of the earthquake. But we are, as a civil engineering, building engineering, we are not interested. That's why I try to bring these numbers come up to replace this magnitudo. That's why this is, instead of strength, we need the comfort. So if you want to design a building, not only strong, but it has to be less shaking, something like that, that we can do by using computers in the design phase. Then we can simulate many probable buildings that meet your requirement. Okay, next. Maybe I can show you, this is an airport in the Sendai. Sendai is a city just close to my city. I'm also in the Fukushima. Fukushima is just maybe 120 kilometers. And we are northern part of Tokyo. You know, in Fukushima, earthquake is very, very big at the time. 2011, you remember there is a nuclear accident. Nuclear accident is very close to my university also, only 50 kilometers near the sea. And this is the airport situation. The airport has been designed very strong against earthquake. You can see here the shaking. Okay, I want to show the shaking. The airport is still okay. They don't fade. But the shaking, you can see. Please click maybe. Maybe you have to click. Not work? Video.
Because of the PDF, Professor, that you sent to me.
Oh, not work? Okay.
Can you click it first?
Click the...
Just the clicking?
Click with mouse.
Okay.
No?
I'm so sorry.
Okay, next. Okay, I just want to show the shaking, how they shake. It's very strong. You know, people's tables are going everywhere, and some glasses are broken, but the building is still there. It's no problem with the building. Then the shaking is a problem. This is the first concept of seismic intensity level. Then we make it quantitative because we come up with numbers, not just strong, not so strong, weak. No, not this. That's not. They are qualitative. You're just following the SNI standard codes. You just following the design code. Okay, it's strong. Then how strong it is? Then nobody can give you numbers. And then we use these numbers by using a smart accelerometer. It's a smart sensor to, of course, there are many already sensors here now because acceleration almost, most of them are accelerations. Then our sensor a little bit different because we add some shaking numbers there. Then there are many useful applications I will show you later. And then we want to standardize the seismic intensity level into the design codes. And that's why, not just force in the codes, that's why instead of relying on static code-based force assume, this has to be included in the design codes too, to how comfort your building. If you want to buy an apartment in 10th floor, 5th floor, or 1st floor, then you have different kind of shaking, believe me. Okay, next. Okay, this is just application. I will go this through very fast because my time is not so much. For example, we want to strengthening a building. Then we can calculate how it shake. Then there are numbers here. We can use number to refer. Then you can make a decision. You can decide which one is better for you. Not just following the codes. Okay, we give this. Then we can compare between many strengthening methods, something like this. This is one of the application. Next. And also if you want the numbers become small, this also is not moving. Actually it's moving. If you use base isolation, of course you will get very less shaking because it's moved like this. But if you're strengthening, it's still shaking. And if you use active control, then how do we know? How do we measure the performance? That's why by numbers. These numbers coming from the human perception. So I combine these numbers with the structural design. Next. And also we can use for structural health monitoring. If you keep the sensor in a building and after a certain time, for example, 10 years, 20 years, then you can compare. When the very beginning the building is built, suppose there is a ground shaking intensity 2.7 at the ground, on the ground, and then your building at that time 3.7, but after 20 years your building is shaking in 5.5. Then we get the kind of description how its building is become weaker. Then we have to do something. We have to do strengthening by using the same earthquake. Okay, this is for structural health monitoring. And also for construction. For construction is very complex because from the building the foundation stage, then we can also monitoring the shaking of your foundation. And then structural framing is just when you have to to stop the construction. At that time, maybe the concrete is not hardened yet. Then so we have to set the limit when there is an earthquake with a certain level of intensity. Then we have to stop the jobs. I mean, the construction works. Otherwise, it's very dangerous. Something that we can use also for alarm, for the early warning, something like that. And then we can final inspection, whether this is the building has been designed according to the first time we designed the shaking numbers. Then we can check after it's being built. Also can be decision support and risk mitigation too. Next, please. And now we are developing the real-time monitoring system. This is what you can see in the ordinary sensor. There are many sensors here, but only accelerations usually. Only accelerations. It means very difficult to understand for ordinary people. And we add here the shaking level. Then it will record the shaking of your building on a certain floor, on a specific floor. So every floor has different dynamics behavior. That's why we save this history of shaking too. This is our new real-time monitoring sensor. And there was a question before whether I can apply this for a bridge or any kind. I can say that any structure which is moving, that the sensor can work. Okay? So a bridge also possible, any kind. Okay? Next. And this is the real monitoring in our campus, in one of the building. I forgot to mention that besides the sensor, we need to do some computer modeling too. That's why the building has been modeled. I modeled the building, and then I put the sensor here. I record the data, and then I check with the computer models. No, this is the way we have to calibrate whether it's the same shaking, not only acceleration. Of course, we record acceleration, and then but we have to process again to get the numbers of shaking. Next. This is the second building. This is our lecture buildings. So I put 3 sensors there. Now I put 4 actually. 1, 4, 7, 9 floor. And then now it's still recording the data. But because in Japan, maybe in a month, we have earthquakes. Maybe 3 or 4 times usually. But usually it's very small. Only seal number 2, something like that. But we can record it. We can show the numbers. Next. Okay, this is also, I put 10 units in fire department buildings in Jakarta. So now they are prepared. We are taking the data, the real data. That's why, and I can monitor this from Japan. Because they allow us to access the Wi-Fi, then I can access the data. Next. We have applied this also for disaster mitigation, early warning. And for early warning, we don't have time to do some structural analysis, some building computation. We don't have time. That's why we have to replace this computer simulation with artificial intelligence, so that it can predict very fast at your floor, a specific floor in a specific buildings. So it has to be customized. So that's why it gives you numbers on every floor of your buildings. Next. If you can see that from the pre-construction, that from design, from planning, we can apply these methods. It's very, very easy because you can calculate the numbers. Not like maybe some of you know modified Mercalli intensity, MMI. MMI has no equation, but only Japanese SIL has equation that we can use that equation with the structural analysis. And then post-construction, we can calibrate. You can apply the active-passive control device. Then you can evaluate, you can measure how performance is by using numbers. So this is quantitative. Not just saying that, oh, your building now is safe because it has a control device. How safe it is, then nobody can answer. Then we need the numbers here. And during use diagnostic, present time, people diagnose the building by using eyes, bare eyes. They see, oh, no cracks, or your building is safe. But that's not enough. Then we need some numbers for this. That's why we do real-time monitoring. It can be used for disaster mitigation. And then also the last one for forensic analysis. It's just like a black box in the airplane. Okay? This sensor like a black box. When the buildings collapse, then we can analyze back by seeing the shaking. Whether your building actually is weak or the earthquakes are very big, which is exceeded the design codes. That we cannot do anything. Then you can do forensic analysis of your building after its collapse. Okay, but we need time history dynamic analysis here. If you want to use for the disaster mitigation, early warning, we need artificial intelligence here to replace the computer simulation because it takes time. Okay, we need these two kinds. Okay, I think I finished with the seal. Now I'm going to go further. When I installed the sensor in Jakarta, I didn't get earthquake sometimes. Then why don't we apply to the wind? Okay, for high-rise building, wind's coming most of the time. And your building is swaying all the time. 100-meter buildings is swaying 1 meter. Have you ever experienced, some of you? Yeah. And then actually that swaying, we can design, we can compute in the beginning, before we build. We can planning. That's why we can do more simulation first before building your high-rise building. Okay? No, this is just wordings. It's not so important. Next. Okay, this is also building, also the same. Same like seismic, wind engineering, the same. They are still using static. Of course, they are doing wind tunnel tests. Do you know what they test? They test just the stress. Then what? If the stress is okay. Right? But if it's swaying, shaking, we can calculate. And how comfort you are. If you're comfort with the 1 meter swaying all the time, then it's okay. Nobody will resist you to stay there. But most of people, I don't think you are comfort with being shaking. Okay, next. Okay, they are using comfortness also, but based on the accelerations that I show you. Acceleration is not so important. It doesn't tell you the comfortness. It depends also on the frequency of acceleration. Next. That's why we try to make a new one for the wind from 0 to 9. Okay? It's principally the same. This is when the earthquake comes. So there are numbers that we can calculate. Now we made a new numbers equation for the wind. Okay, next. Okay, this is application. Suppose we have how many floor? Forgot. Okay, 54 floors. Okay, high-rise building. And we can give synthetic time history velocity pressure of wind. Okay, we can do structural analysis. Then we can see here the numbers of we feel. We feel is coming from how do we feel with the swaying. It's 4.4 on the 24th floor, 42, 54. You get 5.2. Then you can try to change. Next. Then we can try to see by using computer. It's very cheap. Then we can planning before. When there is a typhoon, it is a tropical cyclone. It's from southern of Java. I took this data, synthetic data. And you see here, the B, the structure B, type B, has less shaking. Then we can start constructing something like that. Before we need the planning first, we have to calculate the shaking also, not only strength. Next. And also for the factory, if you want to check some points in your factory also they get influenced by strong wind. Strong wind is very critical to this very long span factory. Then you can get some monitoring some point. When the point is, there are many sounds in the factory when getting older, 10 years, 20 years, it's very noisy. Whether it's still strong, then we can modeling also from the computer and we check, we calibrate. Then we get the numbers here. Next. Okay, I try to search over internet. I try to do some real problems. So I got the Taipei 101. Actually, I also looking for the Malaysia Petronas Tower, Twin Tower, but I couldn't get the data. I only get the data from Taipei 101, and they are very kind. They release in the internet. I got from the papers. Next. And then I got this building structures. It's about 101 floor. And then I inspect also with the tune mesh damper. Some of you maybe already about tune mesh damper. And then, okay, next. Okay. Then, by using computer, we can do simulation before we build. Okay? I don't know how they determine this TMD. Because I made two models, one without TMD and with TMD. And I tried to calculate the first 5 natural frequencies of these two buildings without TMD and with TMD. I didn't get too many difference. Then what does this mean? I hope my calculation is wrong. I saw no difference. Then there's no effect of the TMD. That's what we can conclude here. I hope my calculation is wrong. But this is the first. Second is the swaying frequency. The natural mode, first mode, second mode is the same. It's just X and Y direction. It's diagonal direction and then the torsion, rotation of the building. So it's almost the same numbers. I got the same numbers. Then it means that, I don't know, if TMD doesn't give you any benefit here. Maybe I have to talk with the designer of Taipei 101 later. Next. And then I try to apply the synthetic typhoon. But this typhoon is a real typhoon in 2015 in August 8. And it hit the Taipei 101. And you can find many papers. It's already published. And then the Taipei 101 moved about 1 meter due to this typhoon. And then I tried to calculate, and I get the same numbers with the frequency. It's about 6 seconds. And then with our method, we can compute the shaking of each floor. I choose this is 6, 77, 90 floor. Then we get this shaking due to the typhoon. That's, they don't know, and I don't know. The paper didn't mention about shaking. They just measure the displacement, the accelerations, then nobody understands.
I'm sorry, 3
Okay,
minutes.
next,
Bro.
I hope I can finish fast. Okay, this is the same for wind also. Next, I will jump. And then this is the fire protection. Maybe I can say one easy. After a big earthquake, what you usually do? Usually you evacuate outside the building. And then after you evacuate, are you sure you can enter again the building? Nobody can tell you now. And then if you have these numbers, you can use a signboard. Your building is safe because it's checked only at a certain amount number. Then we can set the numbers with the checking criteria. Then otherwise, people do not know. They don't know how safe is the building is after the earthquake. Can we enter again? Something like that. Even the expert, what they call seismic earthquake expert, they don't know, right? But we need the numbers. Next, okay, I will go fast. And then seal, we fill, and we appeal. So I use the same concept. It's a shaking. It's Indonesian BMKG. BMKG is shaking intensity level. But there is no equation to calculate that. Next. And then now we are developing codes for fire protection. Next. And then this is very important for power restoration, mitigation risk, and data-driven to prevent fires. Next. I just speed it up because I don't have time. And then this is the one that I told you that after the earthquakes, nobody is sure whether they can enter again the building. Then, but if you have a signboard, okay, safe to enter, then you can enter. No, it's dangerous, don't enter the buildings. No, this is very important, very necessary for earthquake disaster mitigation. Next. Okay, this is for earthquake evacuation drill. Next again. Okay, you can use for drill. And then how these three combines together into one concept, very big framework. Okay, next. I think I finished. Thank you very much. Sorry for the extra time.
Okay, thank you so much, Prof. Stanley, for the thoughtful perspective related to the seismic, wind, and fire protection. Okay, it's a very nice presentation. Okay, we come to the last presenter for the keynote speech session. There is a Professor Ji Heo Chen from National Central University, Taiwan. Okay.
Yes.
Good afternoon, Professor.
Good afternoon.
Have
I know
you get
this.
your lunch?
Yeah, this is about lunchtime in your in your area. So I hope I can make it quick, in 15 minutes.
Okay. Okay, thank you. Professor Jie Chen is a lifetime distinguished professor and associate dean of College of Engineering at National Central University, Taiwan, where he also directs the Research Center of Smart Construction, and also his expertise spans construction engineering and management, computational intelligence, and smart city application. Professor Chen also have record of over 100 journal publication and 100 peer review conference paper. He is also a fellow of the Institution of Engineering and Technology and a senior advisor to various government organizations in Taiwan. As people say, we save the best for the last, Prof. So it is time for you, and without any further ado, Prof. Chen, the screen is yours.
Okay, can you see the file? Can you? No?
Maybe you can share screen first, Prof.
So I'm sharing.
Yeah. Okay, we can see clearly.
Okay.
Okay,
So we can see the file, right?
Okay, thank you, Professor.
Okay. Good morning, everyone. I know this is about lunchtime, and it's 11:40 at your time zone. So I will make it very quick, very quick. So thank you again for the opportunity to speak with you today. My name is Jie Chen, and I'm with the Department of Civil Engineering, Research Center of Smart Construction, and the College of Engineering at the National Central University, Taiwan. Over the years, I have also the privilege to contribute to the industry and academia in various capacities. The roles including guest professor, visiting professor in the United States, Canada, Hong Kong, Vietnam, and of course Indonesia, and also editors in several ICCI journal papers regarding sustainability, civil engineering, occupational safety, very engineering, and technology management. And also, I'm the current president of the Safety and Health Association of Taiwan, one of the largest nonprofit organization in Taiwan. And also, I'm in the committee members to 8 ministries of Taiwan government, including public works, labor affairs, national defense, education, transportation, and communication, internal affairs, economic affairs, and examination affairs, as well as in some local governments. And I'm gonna make it very quick. Publish papers, and luckily I'm being recognized among the career-long top 2% of the scientists globally by Stanford University and elsewhere, and also the fellow, and hold a dozen of innovation patents. Today, here. So these patents I just translate into English because it's published in Taiwan. Today, I'm going to show you some examples that I have done in recent 10 years. Let's begin. Okay, so smart construction is no longer a future concept. It's a system combining, of course, computational intelligence and AI technology, IoT, and the sensing networks, in digital twins, BIM, a building information model, advanced materials, safety and risk management, also automatic inspection accreditation. Okay, so our research focus on making construction more efficient, safer, and more intelligent by integrating data-driven solution to traditional workflows. So here we go. Our work spans 10 major domains. Actually, my center has 10 major sub-centers. The first one, as you can see on the screen, AI and deep learning in engineering, occupational safety and health, construction linkage accreditation, house transfer inspection, construction information, engineering forensic technology, urban building renewal, manufacturing, coating automation, intelligent property and patent development, smart material research. So this area together form a holistic framework for transforming the construction industry. Let's go to the first one, smart precast production. On our early stage, so it's about 10 years ago, 2015, our focus on precast construction, where we achieved 24% reduction in production line through process re-engineering and the classification of precast difficulty using computational intelligence, and also 80% increase in profit from labor cost optimization, and also 97% performance improvement using our application. Also time saving and the fair workload distribution via AI-based scheduling. These are published in paper, or we have the patents of course, in Taiwan. So this result highlight how AI can significantly enhance traditional manufacturing workflow. We have everything here. So if you are interested in the details, please go to me, because I don't have much time today, so I just go ahead. This is the another example. We developed a cloud-based IoT platform. Let's suppose a language process, natural language process for project communication. Actually, I have a clip, but I'm not sure is that playable. Okay, if you are interested in that clip, because it's in Chinese version, I will try to, maybe if we have time, I will go back to play the video clips. And also AI assist the project quotation system. So these are all funded by our Taiwan National Science and Technology Council. Of course, I'm in the panel, and also offer a more transparent and efficient contract environment. This is an example showing that we create an delegate intelligent steel coating system, and this is another video. I will try to come back if we have time. And also we have two. I'm sorry, this is in Chinese. We have two patents that I'm going to translate in English. It's an AI-based steel component image recognition, and also an intelligent system for coating path planning. So the innovations improve significantly about the quality control, efficiency, occupational safety in steel coating procedure, because it's very harmful if personnel exposed to the environment while coding. Next, this is for safety inspection and accreditation technology. Because I'm in charge of a big organization. So we conduct nationwide level safety program that includes regulation analysis and the improvement strategy for the government. So I usually go to the government to provide some strategy, and also large-scale survey on risk education and training. We offer more than 300 curriculums in a year, and also risk assessment promotion projects. So we also develop this very interesting a system, so-called crew overboard alert devices. This device can detect when fishermen, this is a fishbowl, when fishermen accidentally fall into the seawater. And this is the how. From this picture, as you can see, I'm the one with head, and we are going to sail out to the sea for testing. So that's the system. Right now, Taiwan government is trying to promote this system to protect, to make sure those fishermen's safety. And these photos are the demonstration for how we conduct those safety training. Again, as you can see, I'm in the photos, and the one next to me is one of mayors in our local government, and we are trying to promote how to conduct, how to do our training to those trainees. The next one is the construction linkage acquisition. Construction linkage is a big problem in Taiwan because Taiwan, as a previous presenter just said, that Taiwan, we have wind, a lot of strong wind, typhoon. We got the earthquake. We got a lot of rain. So linkage is a big problem. So for example, for a year, regular year, we have more than 1,000 litigation cases going on in Taiwan. So our team try to fix the problem. So we create a full automatic linkage inspection system. Also, we standardized operating procedures like SOP, and also professional training curriculums. So far, we have conducted the inspection accreditation works for every district courts, more than 70. Actually, right now it's close to 100 already. So it's a big improvement to the industry. And the next, for the house transfer inspection, again, it's another big problem because usually the contractor or the house seller is not going to tell the entire truth to the buyer. So we work on establishing standards for house inspection professionals. And also we create a certification mark system and a smart inspection app sponsor. And we also have the patent for the app, also the technology. So those texts contribute to higher transparency and the quality in home buying and selling. And this addresses one of the most common disputes in Taiwan in construction industry. And we try to make it make the property, everything transfer safely, not safely, without any dispute. So we are still working on that. For the next one, we are talking about smart city. So it's a hot issue in Taiwan. So when we're talking about environment, so we usually focus on some application, for example, like environmental intelligence, 3D sensing, and the digital twin. So this is the example from my team to build some advanced algorithm for land pollution prevented management. So in this application, we help the local government in our location, so-called Taoyuan City, to classify the contamination resources and develop the strategy for clean land management, particularly for farmland and the industrial regions, because Taoyuan has the largest industrial parts and the regions in Taiwan. So our GDP, the Taoyuan GDP is the #1 in Taiwan. So this is the local government focusing on. Next, we apply AI and some technology on earthwork. So this so-called earthwork management. Here, as you can see from here, except for those algorithms and some charts that we apply UAV, and we associate with, we combine big data and some computation, deep sensor, 3D point cloud technology to pinpoint those earthwork calculation, because someone tried to dump something else, not just pure earth, into that field. So we need to detect and provide real-time monitoring. Next example is the digital twin and the beam with AR and the LiDAR. As you can see here, this is the theory. I'm sorry. Next page, we provide an adaptive clustering method that explode beam field integration and AR assessed on-site visualization, as you can see from this picture. This is the twin. I'm sorry. This is a digital twin, and from the behind of those facility, people cannot get access to those areas. So we need to combine. We need to integrate those AI application in order to do the best guess what's going on behind those facility. That's one of our part. That's part of our focus right now. And also, in the end here, we try to do some material research because for this example, we are working on a new material. So this is not a new material, but we try to make it bring it to new component to our construction material or some applications. So we try to the material I show here is balsa, and I try to collaborate with other universities in Taiwan, and we try to make it work. And then right now, this one is on the way to have the patent, United States patent. So I cannot talk too much here. In the end, for international collaboration, my team has collaborated intensively with the University of Massachusetts. As you can show here, for structure-related work, for some image, radar image, SAS image, and some applications and collaboration with the Concordia University, Canada. We are talking about some application or some calculation. So those pictures I showed previously. So that's the collaboration with the professors in Concordia University. And also University in Vietnam, of course, Indonesia and the Philippines. Under our new southbound policy, our government is encouraging all possible collaboration. So this partnership support the joint research, student exchange, and international academic development. So in the end, I would like to say smart construction. I just show you some example. Smart constructions is a transformative force from AI-driven application to intelligent safety system, from digital twins to environmental sensing. We are entering an area where construction becomes data-driven. Okay, of course, automatic, safer, more sustainable, more predictable, and efficient. So our future work. Okay, so I only spend 15 minutes. Okay, I'm going to close my my presentation. If you have any question, welcome to ask me by email, anything. So our future work is aiming at expanding digital twin system, also enhancing human machine collaboration, and integrating robotics into construction, strengthening environmental and safety intelligence, and of course, continue international collaboration. I think that will be all. If you have questions, please. Thank you. That's all. That's my presentation today. Thank you.
Thank you so much, Professor Chen, for the insightful presentation related to the smart construction. Like AI for everything, AI for all stages of the construction, right?
Yeah.
Okay. Okay, we have now arrived at our second Q&A session. following the completion of all 5 keynote speakers. If you have any question, please do not hesitate to raise your hand. We have, wow, so many. Maybe 3 first from the other side. The blue one, and then in the center, okay, and in the right, has a student in the back side. Okay, please. The first one, please.
Okay.
Your state your affiliation and your name. Thank you.
Thank you for your opportunity. My name is Tanjung Mega Dubuspita. I'm from Implementation Unit for Water Supply, Ministry of Public Works. I want to ask for Mr. Commander, considering the challenge typically found in dense and fully developed urban environment, such as limited available land, existing gray infrastructure, and competing demand for space, what comprehensive strategies or approach do you see as most effective for successfully integrating green infrastructure or nature-based solution into these already built up areas? Additionally, how can cities ensure that such interventions remain functional, scalable, and community support in the long term? Thank you.
Is that where I understand? Okay, maybe we will move to the second first, or you have to directly to answer? Okay, just to the second question first, right? Okay, the second question from the center, Pak. Okay, thank you.
Thank you. My name is Andrea. I'm from the National Road Implementation Agency in East Nusa Tenggara in Kupang.
Nice.
So we are planning to build a 140 kilometers road of Northern Corridor in Flores Island. It is near Labuan Bajo. It is a growing tourist destination near Bali. And our current concerns are about land conditions and coastal abrasion or erosion. But after learning from your presentation, your experience in several countries, we are also thinking about long-term potential problems. My question is, from your perspective, what kind of additional coastal protection or coastal risk should we anticipate in the future? And also what sustainable, cost-effective, and tourist-friendly coastal protection measure would you recommend to Labuan Bajo? Thank you.
Okay, this question dedicated for the Mr. Commander, right? Okay.
Yep.
And the last question from the students in the back side. Okay.
Yes, thank you for the opportunities. My name is Destia. I'm from Building Construction Engineering. Your presentation on Shell, fuel, and FIPIL as quantitative intensity frameworks for disaster resilience and sustainable infrastructure resonates with our works in ways to work to value concrete innovation, like innovation in concrete, like carbon S to switch the material. Now, so my question is, how can frameworks such as Shell, refill, and FIPIL be applied to evaluate, validate, and accelerate the adoption of waste-based material innovation, ensuring they move beyond research and into the real infrastructure implementation? Thank you, Prof.
Okay, this question also for, I think for the Professor Gan or Mr. Commander? Professor Gan, right? Okay. Okay, maybe for the, for. Can you repeat again, Destia, for the question? It's related for Professor Gan, right? Or maybe you want to use the Indonesia?
Oke, mungkin dalam bahasa Indonesia saya ingin menanyakan terkait bagaimana framework untuk Shell, refill, dan refill untuk mengaplikasikan inovasi dari penelitian saya dan tim saya terkait inovasi pada beton bisa melalui beberapa inovasi green material begitu. Terima kasih.
Okay, so you need some clear suggestion, right, related to your research, maybe for the research about the concrete, right?
Yes.
Okay. Okay, maybe we want to answer the first and the second question from the audience, please, Mr. Commander.
So I think the first question is very comprehensive. So I think what we see in the field is that the civil engineer is slowly becoming a manager. And nature-based approach, it doesn't only mean understanding what is the physics, because a civil engineer knows the physics, right? We know if we build a canal or a dike or a coastal defense, what are the waves? We can do that for many decades already. But what we see changing is that it becomes integrative. So work with social, work with environment, biodiversity, all kinds of things that are happening there. The economics, what are people doing in your area? Finance, can we actually pay for it? Maintenance, not only the structural side, but also the whole package. Can the community, including the institutions, carry this kind of infrastructure? So what you see is that it had to come to sustainable, more resilient solutions. We tend to move towards very integrated approaches, starting at very high level. What do you want? What do you want? What do you want? Okay, I hear this, I hear that, I hear that. And you slowly converge into something that is suitable, not only for the water infrastructure, but also for all those domains I just mentioned, right? And then you come up with more resilient results. Now, major Southeast Asian cities, they're very challenging because a lot is going on. And that makes it very exciting for us, civil engineers, to work in this, to really come up with solutions that fit the broader audience and that can carry for many decades, basically. I hope I responded to your question, because you're basically asking me how to do it. Well, this is what I see, how we start to do things. Yeah.
And the second one from the...
So yeah, the second one,
the coastal
also
prevention.
Yeah, also a difficult question to answer here on stage, because reflecting to what I just mentioned to the previous question, what does fit in Labuan Bajo? I don't know. I can give some examples, but actually it's the process that I encourage you to start, right? Start talking to the different people that live there. Start talking to the different ministries that are responsible, not only PU. And yeah, try to organize that and see, if I do a massive coastal defense structure, what else is needed in that area? And what should I be taking into account? Now, I learned a lot by working with architects. So you're from the Department of Architects, but you're a hidden civil engineer, you explained to me. But they are very good in organizing this chaotic process in the beginning. And I think that's my main comment on both questions, basically. Challenge yourself to enter that kind of chaotic period before you come dropping with a solution. What we often do as an engineering consultancy internationally is people like to see a solution, so we put something on the screen and then we get reactions, right? Maybe it's not the right solution, but we do get a lot of feedback. And from that feedback, we start developing into a more reasonable solution, basically, or a more suitable solution for the area or the challenge that you're looking into. I'm happy to show more examples for coastal defenses one-on-one. We have tons, and that may act as an inspiration to you. But again, it's all tailor-made stuff. Yeah.
Okay, thank you so much. Is that clear enough? For the first time is here and sit together maybe, sir, for completing every problems. Okay, and the last question from the student, maybe we need to discuss more, right, Professor, outside, or maybe Destia clearly can discuss with Professor Gan for the next session, right, Prof? Okay, we open for the second Q&A. Is there still any question maybe for the Professor Chen? Because we have Professor Chen in the, maybe I will choose first the backhand side, the student. The back one, but okay, the first, and maybe the other, the second. Okay, just two is enough, it's okay, because we have a limited time. Thank you. Okay, the first, please. Thank you, Professor. The first, please. Okay. Yeah.
Good afternoon. Sorry, but my question is actually for Professor Buntana.
Oh, okay.
Yeah. So first of all, I'm sorry for Professor Chen. First of all, my name is Wilke Sibiang Lala Satyana Gusti. I'm a student from Technology Construction of Water. The question is that I want to ask about the AI in seal seismic intensity level for disaster. So how can AI improve the accuracy of seismic intensity level predictions compared to traditional seismological models? Thank you.
Is that clear enough, Professor? Yeah. Okay, you want to directly answer?
Thank you so much for interesting my SIL, seismic intensity level. Yeah, actually I already published a paper for the AI one. Maybe you can, I can give you later. The AI has input to predict the SIL. First, the magnitude of the earthquake, the distance to your building, and the number of floors you are interested on in the building. And then the distance, the depth of the earthquake center, and this kind of inputs, and we can predict less than 20% error of the SIL. And now one of my PhD candidate in Diponegoro University is doing AI also. Now we include the soil properties to make it better prediction. I hope we can reduce the errors. Is that answer your questions? Yes, thank you so much.
Okay, thank you. The last question come from this side. Mbak, okay, please.
All right, thank you for the opportunity. My name is Dini. I'm from Universitas Gajah Mada, Indonesia. My question is, the model precision seal with FPIL as quantitative drivers for earthquake resilient and sustainable infrastructure. However, Indonesia's biggest challenges today are not limited to seismic risks, but also the combined failures of aging infrastructures, low digitalizations, and rapid urbanizations. In this context, how can these frameworks practically guide the redesign of Indonesia's future cities through digital twins, AI-driven monitoring, and predictive maintenance, so that the resilience is not only calculated, but truly embedded in the system? Thank you.
Okay, actually this question can for Prof. Buntara also. Maybe you can share your experience also, Prof. Chen, how to maintain the smart construction into the reaching the future. Okay, maybe first Prof. Buntara first, or maybe Professor Chen, because your face is quite big here. Okay, first for Professor Chen.
Well, because smart construction has many domains. So it totally depends on the interest that student may go to. So for example, like a digital twin, it can be a good application because in Taiwan, everything, not everything, I would say large scale construction we are talking about is for the government is requiring digital twin and a big model to monitoring and to maintain a database for all the contracts. So I don't know in Indonesia, maybe it's the future. So I also asked my student to run a company. He has a number 3, a large company in terms of BIM. So they are working on our new airport construction. So it can be a very good application in terms of a smart construction or AI enhanced project. Okay, that's my quick response.
Okay, thank you so much, Professor. The next and the last, Professor Buntara, to replies maybe the others.
Sorry, can you repeat just the main point?
The main point?
Just short questions. No? Maybe you already get the answer from Professor.
You get the answer for Professor Chan, or you want to next for Professor Gan? That's enough?
Maybe because my face is
thank you.
to scare them.
Okay, ladies and gentlemen, as we come to the end of the session, we are reminded that building a sustainable construction future requires not only vision, but also commitment, innovation, and collaboration across border and disciplines. On behalf of organizing committee, I would like to extend our sincere gratitude to all the speakers, panelists, and also the participants who contribute the meaningful discussion. Thank you once again for joining us. Have a wonderful day and see you at our next event. Thank you for attention, and I will now hand back to the Master of Ceremony.
Okay, let's give a big round of applause. Thank you so much to our moderator and also speakers for the insightful session. May we kindly invite our honorable speakers to move forward to the stage. We will now move to the next agenda, which is the presentation of tokens of appreciation to our speaker. So we kindly invite Mr. Insinyur Brawijaya to come forward and present the tokens of appreciation. To Mr. Indratmo Soekarno and Ms. Chitra Islami, we respectfully invite you to please come to the front of the stage to receive your token of appreciation. And I would like to invite Mr. Syamsul Bari to join us on stage. We will now proceed with the appreciation for our speakers. And also Mr. Iriandi, please kindly join to the stage. To all of honorable speakers and also moderator, please move a little bit forward to the stage. And we will take a picture together. And I will count down. In 3, 2, 1. Give the best smile at the camera. Ladies and gentlemen, as we conclude this insightful session, we would now like to take a special moment to express our deepest appreciation to our distinguished speaker, Their valuable insight, forward-thinking perspective, and generous contributions have enriched our conference and inspired us to continue advancing innovation within the construction industry. We will now proceed with the appreciation for our speaker. So ladies and gentlemen, let's give a big round of applause. This plaque symbolizes our gratitude for the knowledge shared today, and we hope it serves as a reminder of their meaningful role in shaping the future of sustainable construction. Ladies and gentlemen, let us give a warm round of applause once again to our esteemed speaker as we present this token of appreciation. Thank you so much. Please kindly back to your seated. Thank you very much. And ladies and gentlemen, we now have come to the lunch session served in the dining area. Please enjoy your meal and take this opportunity for further networking. We will also like to remind you that the following session is the breakout session that will begin in the designer room. So please proceed to your assigned room after finishing your meals. And we would like to announce you that after the lunch, we will continue with the breakout session in the assigned room. So please proceed to your desired breakout rooms and our team will help you. Thank you very much and have a good rest. Ladies and gentlemen, we would like to announce you that after the lunch, we will continue with the breakout session in the assigned rooms. Please proceed to your designated breakout rooms and our team will help you. And for ladies and gentlemen that already have been lunch, please back to your seat because after this, we will continue the presentation. Once again, I would like to remind that for ladies and gentlemen that already have been lunch, please back to your seat because after this, we will continue our presentation. So please kindly back to your seats. Thank you so much. Okay, good afternoon, ladies and gentlemen. We will now continue with the next presentation session. It's okay if you still have lunch, you may listen and look forward to the presentation session. And for this presentation, we would like to invite our moderator, Ms. Ingarawi Sekaringbumi, to lead the session. Good afternoon, Ms. Ingarawi. The floor is yours.
Okay, thank you, Miss. Good afternoon, everyone. It's such a joy to see this room filled with brilliant minds, passionate innovators, and people who truly care about the future of our built environment. My name is Inge, and I'm very honored to be your moderator for our invited speaker session today. Now, we'll journey through ideas, research, experience, and dreams brought to us by incredible speakers who have dedicated their lives to shaping a sustainable future. So please, give me your 3 hours to stay beside me and focus with our marvelous speaker. Now, I would like to invite our speaker to join this event. Our first speaker is Dr. Reyes Garcia, from Associate Professor of Structural Engineering at the University of Warwick, UK, who will join us via online meeting. Mr. Garcia, can you hear me?
Yes, I can. Good afternoon to everyone.
Okay. Are you ready to present your presentation?
Yes, I am.
Okay. Before you start the presentation, I would like to inform your summary information. Dr. Reyes Garcia has over 25 years of research and consultancy experience. His work spans sustainable concrete, FRP composite, and earthquake engineering. He has led major AU and Research Council projects, coordinated large-scale shake table experiments across Europe, and published more than 100 scientific work. Now, Mr. Garcia, you'll have 25 minutes to present your presentation. Would you like to start now?
Yes, I can. Can you see my screen now?
Okay.
Yeah, can you see my screen?
Yes, we can see your presentation.
Okay, perfect. Well, thank you very much for the invitation to present. Thank you also to the Public Works Polytech for the invitation to speak to you. I thought that one of the most interesting things I could show you today is some of the recent work we have been doing regarding damage assessment and recycled aggregate concrete. This is in collaboration with some of the universities also in Thailand. My details here, whether you have questions after the presentation or even later on, you can always get in touch. As I said before, this is basically some of the work we have been doing, and I'm happy to establish any collaborations you may think of. This is the contents of the presentation. After a brief background, I'm going to move very quickly to spend most of my time talking about recycled aggregate concrete, why we should be using it more in construction. And then later on, I'm going to speak about some of the damage identification work we have been doing to assess damage in buildings. And then eventually we'll reach the conclusions and main takeaways from this presentation. I suppose the first question is why we want to use waste in concrete. And there are several reasons why we want to do it. One of the things is that many of the buildings in many of our cities are reaching their end of life service. So we have basically 2 main options. Either we recycle the buildings or we try to extend the service life of those buildings. Every time I travel to Asia, I was actually in Indonesia just a few weeks ago. I see lots of construction going on, renovation of the city centers and many areas being developed. we have to do something with those buildings and houses that are being demolished. So we can either recycle them or try to extend their service life. Now, if you think about it, concrete is the most used material in the world after water. For each of you sitting in the room, every year there is around 3 or 4 tons of concrete being cast. So if you think of your life, hopefully a long life, there is going to be a lot of concrete being cast. Yeah? So we need to do something to supply materials for that concrete. On the other hand, we also have a supply and demand issue here. The construction industry produces a lot of construction and demolition waste. On this plot here, we can see basically that's the production of construction and demolition waste. Most of it comes actually from Asia, China, India, but also Southeast Asia is a high producer of this waste. Europe as well, but mainly most of the waste is actually coming from Asia. On the other side, we also have this other figure here. Most of the demand of raw materials for concrete is also coming from Asia. So we have a big supply of construction and demolition waste on the one hand. Then on the other one, we also have a high demand from raw materials. So I think there is a good case here that we can make and say that actually it makes sense to try and use as much of the waste we produce in construction itself. Now, if we think of concrete, most of the materials we get from demolition is basically looking at this plot on the left. Most of the material we get is actually concrete and masonry. So it can be up to 84% of concrete and masonry. And that material can be used as aggregate in new recycled aggregate concrete, basically replacing the natural aggregates, the sand and the gravel. This is not so trivial because it has some technological and scientific challenges, but also if you consider in terms of the bulk, it makes sense to try and replace the aggregates because that's the bulk of the concrete. If you see here this figure, most of the components of concrete is actually either coarse aggregates or the fine aggregates. So as a bulk, the recycled concrete aggregate can be used to produce new recycled aggregate concrete. Now, using recycled concrete aggregate, that's basically the chips or the sand coming from demolition, is not a trivial thing. RCA, that's basically the chips, the recycled concrete aggregate, is usually more porous and weaker than normal aggregate we get from riverbeds or from the quarries due to the adhere mortar. Every time you demolish concrete, there is going to be some mortar there that sticks to the aggregate chips. Also because of cracks due to the recovery production, many times we basically break the concrete, so that's going to produce some damage to the recycled concrete aggregate. And that's why characterization of that RCA is critical to know the properties, how they behave. Now, just to give you an idea, in terms of the porosity, I have this plot on the left. On the vertical axis, we have the water absorption after 24 hours. And then on the horizontal axis, we have the results from different researchers. This is actually coming from a paper we published recently. This is basically looking at natural aggregates. That's the dark column here, which looks like red. And then the other columns, it's basically recycled concrete aggregate, the orange columns there. And as you can see, in terms of water absorption, the recycled concrete aggregates always has a higher level of water absorption. And that implies that you need to increase the water you use in the mix. And obviously that's going to reduce the concrete strength. The other thing that RCA does when we try to on the right, in this case we have basically compressive strength on the vertical axis, and then again results coming from different articles available online, and then we compare natural concrete made with natural aggregates, that's basically the dark column, and then the orange one, is the recycled aggregate concrete. And as you can see, in all cases, the compressive strength of rack is reduced by anything between 2 or 3%, but up to 30%. So as you increase the amount of RCA into the concrete, then that also has implications because it reduces the strength of the rack. And that this is basically just to reiterate, there is obviously a size and percentage dependency depending on how much RCA you're replacing in the new rack. Actually, if you want to use small amounts of RCA in concrete, it's okay. It's actually allowed in the codes. ACI and Euro code allow you to use around 20-30% of RCA into new mixes. And you can use the same equations you use for design because you change very little the properties. Things get a bit more wobbly when you get to around 50-60% level of replacement of the aggregate using RCA. And obviously, if you want to do the full replacement of the aggregate using recycled concrete aggregate, that's when you basically kill the strength, and then you have to do something about it. And then as we were progressing with the research, we thought, well, is there actually an easy way to increase the compressive strength of that low strength rack so that we can use it in structural applications? So what we thought is of using a technique that we called post-tension metal strapping. This is trying to use active confinement as a way to strengthen that low strength rack. I'm going to show you that video there while I'm speaking. That's basically me when I was much younger and I still had lots of hair. But basically what we do is we use very simple tools and materials as those used in the packaging industry, to pack boxes. And what we do is we put it around the concrete. So we use a simple strapping tool, then the jaws, and then the steel straps. And what we do, you can see now, we are basically tensioning those straps around a concrete element. As we apply the pressure, clearly we are confining the concrete. And then with those clips, you can see there the metal clips. I'll be clamping those ones in a minute with the jaws. What we do is we keep the post-tensioning force in the straps, and by doing so, we're applying active confinement around the concrete. If you think about it, what we're doing is essentially the same thing that weightlifters do in the Olympics to take more load. Weightlifters belt themselves up, so they put a belt around, and they can carry a lot of weight, and that's basically what we're doing with this technique. To give you an idea of what the technique can do in terms of increasing the concrete strength and also the deformability of the concrete, I have this plot on the left. On the vertical axis, we have the stress, that's basically the compressive strength of the concrete. And then on the longitudinal axis, we have the deformation, so essentially the strain, the actual strain on the concrete. And then we have different lines there. The line that says control, this one here at the bottom, that's essentially a test on a concrete cylinder without any PTMS, without the metal straps. So you get a strength of around 30 megapascals, and then this level of longitudinal strain close to 0.01. And then this line here at the very top that says S prime equal to 0 millimeters, basically this cylinder here, that is fully confined using those metal straps. And as you can see, the strength of that cylinder increased to around 47 kilonewtons. And also, most importantly, we also increase the deformability of the concrete, which is many times what we also want to do, for instance, in earthquake-prone areas like in Indonesia. Now, I'm going to show you some work we have been doing with PTMS applied to rack. But before that, used to tell you that we have done extensive work on normal concrete. I don't have the time to show you the results from beams, beam column joints, and even a full-scale building we did. But if you are interested in knowing more about this, please get in touch, and I can give you some more information about the technique and the effectiveness of the technique at improving the behavior of concrete. So this is some of the work we have been doing with the application of PTMS on recycled aggregate concrete. We basically started at the very basic level, trying to understand how the metal straps can improve the strength and the formability of rack cylinders. And what we did is we basically tested simple cylinders with the metal straps around in pure compression. We consider different configurations of the straps depending on spacing. Some of them scarcely spaced, some of them fully confined. So essentially what we have here is 4 cylinders. This one here at the very right, that's a cylinder with full confinement all the way from the top to the bottom. And then there are 2 layers of straps around that cylinder. And then we have some of the results here. On the vertical axis, we have the increments of strength of those cylinders. And then we have the different cylinders here on the horizontal axis. You can see 4 columns. Each of these 4 columns corresponds to each of these 4 cylinders here on the top right of the slide. The black column corresponds to the very last cylinder, which is the one with the heaviest level of confinement. And as you can see here, the strength of that cylinder was increased by up to 200%. This is in percentage, the vertical axis. And that led to a strength of around 60 megapascals, which is a concrete, a recycled aggregate concrete you can actually use for structural purposes. We also proposed a model based on regression analysis and the experimental results from our tests and other tests, and the model works fine. If you're interested, I leave you here the paper. You can also get in touch. I can give you the paper to look at the model more closely. After we did the tests on the cylinders, obviously we know that cylinders have no columns. So we tried also the metal strapping on more realistic columns. So we tested longer elements. You can see here on the photograph the configuration of the straps. In this case, again, we tried different spacing of straps and going all the way up to the full strapping condition. Here on the vertical axis of this plot, we have basically the axial stress. That's essentially the strength of that column being compressed. We also use different levels of eccentricity to produce some bending moments on the columns. And again, we have here 3 cases. The first one here, the line at the very bottom, that's the unconfined control column. That's a column without any metal straps. And then we increased the amount of metal straps. You can see here this plot at the end. It's basically confined, fully confined specimen. And clearly we're increasing the strength, but again, the formability. Yeah, that's something we want to get, especially in seismic zones. Obviously, there is an effect as you increase the eccentricity in a column. The effectiveness of any technique you use decreases. So there is also an effect there coming from the slenderness and that applied moment you have on this sort of slender columns. But in general, the results were very good in terms of how much you can increase the strength and the deformability of longer columns. We also did some work on slabs cast with a rack. This is basically looking at composite construction. And I particularly believe that this is an area in which rack has a lot of potential. And what we did is we cast some beams. These are simply supported beams using a metal base here also to cast on the rack. And we did different types of tests, some of them looking at the long-term behavior, trying to figure out how much deformation we were going to get. We also did some acceleration tests on the slabs, comparing normal concrete slabs versus rack slabs. And then we also did a human-induced vibration test. So we asked people to basically jump, jog, and then run on the different slabs, trying to figure out the level of accelerations the slabs were experiencing. And what we found is that both in the ultimate and service behavior of the slabs, the behavior between the normal concrete slabs and the recycled aggregate concrete slabs is actually not much different. Clearly, we are reducing the modulus of elasticity of the concrete. That has an implication. It increases the vibrations. But in other cases we examined, they basically complied with the service requirements in the codes. We also did some fire testing on composite slabs, again looking at the behavior between normal slabs with normal concrete. That's basically shown here in this plot at the top, where we have the temperature on the vertical axis, and then we have the mid-span deflection on the horizontal axis for different slabs with different levels of replacements of RCA. So as far as I remember, the test, this test lasted for 2 hours. Obviously, the amount of heat increases in the slab because you are accumulating thermal mass, and then you let it cool down. That's basically why you see the spots coming down here. And then here at the bottom, we have the behavior of rack slabs. So we have normal concrete slabs versus rack slabs. This one here is basically an outlier. But as you can see, the behavior in general is very similar. So again, in terms of fire behavior, the behavior of normal concrete slabs and rack slabs is not that different. This is some of the most recent work we have been doing, and much of this work is inspired by some of the issues faced in Eastern Europe and in general in some countries in Central Asia. In Central Asia, after the Second World War, they built many buildings called Khrushchevskas. These are basically prefabricated buildings that used lightweight concrete to build the walls and the panels of those buildings. And in the last few years, there have been lots of issues with serviceability and even some collapses of the buildings just out of nothing. Many of those buildings are reaching now the end of life service, and therefore there is a need to extend the life of those buildings. So what we did is try to identify damage using essentially infrared images. So using images coming from satellites and essentially convolutional neural networks, we trained models to figure out if there was a heat leakage coming from a particular building. So you can see here, for instance, for different years from 2015, 16, 17, and 18, if you take the image and you do some manipulation and you train the models using CNN, you can probably see here at the bottom a little pixel there that is brighter than in the rest of the photographs. That basically raises the flag, and that's an indication that something is happening in that building. We also validated the building, because sometimes when you go to these buildings and you look at them from the outside, you cannot really see much of the damage. That's basically this photograph here at the top. But then if you use infrared images or thermal imaging, you can see there are actually cracks and the heat is basically coming out. These buildings, this research was made in Kazakhstan, by the way. In the winter, you know, Kazakhstan is very, very cold, but then the heat inside the buildings is kept constant, and that's why we can use this technique. And the model was successful at detecting damage, identifying buildings that have potential issues, potential damage, in up to 88% of the cases. And along the same lines, again, looking more at the material level, in this case, at the lightweight concrete panels that are used for those buildings, we identified some buildings that we could actually extract some concrete from there and do some tests. And then we also cast additional lightweight concrete in the laboratory to expose it to two conditions. One of them was essentially damage, so trying to pre-damage some of those cubes you can see in those photographs at different levels, 20%, 40%, 60%, 80%, and so on. And also to produce some freezing and thawing on that concrete. Again, in Europe, we get lots of snow over the winter, and then it gets very hot over the summer. So we have those cycles there that affect the durability of the concrete. On this plot here, you can see this is essentially the residual strength after you apply freezing and thawing and damage. And then on the horizontal axis, we have the thermal conductivity of that concrete. And as you can see, it's almost a sort of linear relationship. It's not quite linear. There is a nice curve shape there, but there is a very strong correlation between damage and freezing and thawing that can be simplified in an equation. That's basically this equation here. That's what we proposed in that article. That can tell us how much of the concrete strength is left after some potential damage, and that combines with the freezing and thawing effects. And then that was validated. We extracted cores from real buildings to validate the equation we proposed. So the main conclusions and takeaways, it's clear that many of our buildings, many of our structures are getting to the end of their service life. So we have, from my point of view, the main two options is either we try to extend the life of those structures by trying to detect some of the damage and repair it, or we can try to recycle the material and reuse it later on in construction itself. From my perspective, there's a lot of potential for the use of RCA in recycled aggregate concrete, particularly in structural applications. I think for slabs, the landscape is particularly promising because most of the times slabs are actually dominated by serviceability. So not ultimately limit state, but serviceability, that's something we can actually control quite well. However, there are challenges because concrete and RAC is a family of materials, and therefore we need to characterize both the RAC and the RCA to understand how the materials behave. Strengthening of RAC, of recycled aggregate concrete, is always possible using metal straps or any other confining technique you may think of. But obviously, there is also the issue of cost effectiveness. If you want to use, for instance, internal steel fibers, that's going to increase the cost of the concrete. And then particularly in some places in Asia, it's very difficult to compete with normal concrete. Our research shows also that AI and machine learning in damage identification is feasible, especially if you are trying to do the assessment of damage for buildings in large areas. I think that's probably the only plausible way to go forward, because you cannot be sending teams to every single building. So you can do it using AI for much larger areas. Obviously, there is a need for better understanding of durability, still in concrete, geopolymers, in new materials, especially you can see probably in the news extreme climate in Indonesia, Thailand, Malaysia, all the floodings they have, so that we can increase also the resilience of our structures. And another thing is obviously guidelines and codes. We need to collaborate more and harmonize the research so that we can think of developing better codes, more efficient, and also think of our buildings as assets that need to be recycled at the end of their life. So we need to think more of design for deconstruction, for instance. And with that, I conclude. Terima kasih banyak. Also, thanks to Professor Njai from Burapaya University, who did some of these tests I presented today. I'm sorry I cannot join later on the Q&A session, but I'm open to receive questions, comments online. Just drop me an email. And any opportunity for collaboration, I'm also open to those ones. I leave you there my contact details. Thank you very much. Terima kasih banyak. I cannot hear anything, but
But if you have another occasion, it's okay if you want to leave first. So do you want to leave first or do you want to stay?
Yeah. No, I need to leave because I have a lecture in 1 hour, so I need to go to university.
Okay, I would like to say thank you so much for your attention in this event.
Thank you very much. Terima kasih banyak, everyone. Bye for now.
Now we're going to continue our session by calling all of the speakers into the stage. We're going to we're going to call our second speaker is Prof. Arif Budi Harjo from Universitas Diponegoro. Please join me in this stage. Now we're going to call the third speaker is Professor Dr. Rini Kusumawardani from Universitas Negeri Semarang. Please accompany me in this big stage. We also have an online speaker. There are from Ghent University and Queensland University. We're going to call our fourth speaker is Ibu Zuni Asih Nur Hidayati from Ghent University who joined us by Zoom meeting. Hello, Bu Zuni. Can you hear me clearly?
Hello. Okay. Yeah, I can hear you clearly from here.
Okay, I hope you will stay a while. Yeah. I hope you will stay a while because we will call our last speaker first. We're going to call our last speaker is Bapak Rian Mantasa Salve Prastika from Queensland University, who also joined us by Zoom meeting. Bapak Rian Mantasa, have you stayed at the Zoom? Okay. Before we dive into this, our incredible presentation, I'd like to share a gentle reminder for all of our speakers. Each of speakers will have 20 minutes to present their research. Feel free to shine, inspire, and let your passion to take the stage. And just like the previous session, we will have a question and answer at the end of all presentations. So for all of the audience, please hold your question until the end of the session. Okay. Now we're gonna listen to our second speaker. He is someone whose insight always grown us, reminding us that sustainability begins with responsible environmental stewardship. Please welcome Prof. Arif Budi Harjo. You have 20 minutes to present.
All right. Thank you, Mbak Inga. Yeah. All right. Yeah. Good afternoon, ladies and gentlemen. Prof. Rini, and also other speakers. I'm really glad to be here today and in front of you. Actually, this is a very good event, and I don't expect that the event is this big. Yeah. So congratulations to Public Works Polytechnic, who is able to held this international meeting. All right, for my topic actually, I'll go a bit shifting from civil engineering into environmental engineering. So in this occasion, I'd like to talk about mainly about the landfill liner. Yeah. So the topic that I'd like to discuss today is related to reinventing landfill liners from environmental risk to sustainable engineering solution. Yeah, next. All right. This is a data that actually we are facing nowadays related to the waste generation in Indonesia. And this problem is quite close to our daily life. In total, there are like about 37 billion tons of waste generated each year. So it's kind of very, very huge number. And Indonesia government has already tried to face this problem with some activities. For example, they perform to do the waste reduction and so on, but the result is not like what we expected. So for the reduction itself is only about 1.3%. So it's very, very small number. Okay, yeah. And pointer yang mana? Yeah, and then the main problem actually, we got like a 67% or nearly 70% of unmanaged waste. Yeah. Nextnya mana? Okay, all right. Excuse me for this thing. And this actually is the problem, serious problem that the people of Indonesia face these days. So most of the waste actually goes directly to the landfill without any prior treatment. And I can tell that the big percentage of food waste actually is kind of opportunity for us to treat the waste before we go to the landfill, before we send them to the landfill. Yeah. This is a kind of overview how is actually the waste generated by people in ASEAN countries treat in each country. So for example, in Singapore, most of the waste is treated by incineration. They burn all the waste. Most of the waste is burned. But if we see in Indonesia, actually, most of the waste goes to the open dumping site, which is untreated. So this is kind of a very serious problem. And in this practice actually also occur in some of ASEAN countries. So solid waste generation, solid waste management, solid waste problem is not only happening in Indonesia, but also occur in some ASEAN countries. Next. So, what is exactly the effect of unmanaged waste? We already exposed with some news, some fact that we know exactly that unmanaged waste give us some various issues. For example, I took this example from the news. One problem is related to the microplastic. The second one, we have overloaded landfill, and I think this case actually happened in most of the areas in Indonesia. The third one, huge pile of waste, about 50-meter mountain of garbage, is also become a problem in most of the landfill. And the last one, the government now try to close the open dumping landfill in most of the cities. I think this is a good action, but then is it going to solve the entire problem, or is just like a popular action that cannot be realized in the near future? So next, yeah. I do believe that all of you is already quite familiar with all these issues. For example, the upper left, actually, this is the situation that happened in most of the landfill in Indonesia, and then the upper right, actually, unmanaged waste can go easily to the river, can go easily to the water body, and they will reach directly to the ocean and will disturb the ecosystem. And also, some of the community has traditional ways to handle their solid waste. For example, just by easily dump it into the river. So this is the picture that already happened in Indonesia and we can see in daily life. Next. So according to that issue, actually, we try to focus on landfill research. And the research actually triggered by some reason. For example, the number of landfill in Indonesia reached almost 300 landfill, 300 locations. That's the registered one. As we know that, we also have the unregistered landfill or illegal dumping site. So the issue is really big issue in Indonesia. Next. So, what is actually happen in landfill? Is that landfill really solve our waste management issue, or is just kind of another way to sift the problem? So basically, landfill generate approximately 11% of total global methane. So they emit methane about 11% annually. And it's also contribute to the greenhouse gas. Yeah. So the methane itself is about 84% more potent than carbon dioxide. So we can see that even we already send the waste into the landfill, but the problem is not just sit over there, but the problem will spread all over the world, not only all over the region, but all over the world, because it goes up and then it will affect the atmosphere directly. Next. So basically, there are a kind of standard for a modern landfill. In order to reduce the effect to the environment, there are some developed model for the modern landfill. Basically, a landfill is kind of closed containment that will contain waste for a long period of time, prevent the gas escaping from landfill, and also prevent the leachate escaping from the landfill site. This is the basic principle of the landfill.
So, according to the previous slide, actually, there are one important component in the landfill that we call landfill liner. So, landfill liner basically will be built on the bottom at the bottom of the landfill and also on the top of the landfill to prevent the gas for escaping to the atmosphere. The liner at the bottom will prevent the leachate to enter to the environment. So basically, the liner in the landfill will function to protect the environment for the activity what occur in the landfill. Yeah. However, some of the liner has some issues. For example, most of the liner made from clay. In Indonesia, most of the liner construct using clay. Clay actually is very good material that has a very low permeability that will seal when wet, but then not only seal but also prevent the gas and also the leachate to enter the environment. But there is some problem with the clay actually. Clay has swelling and cracking mechanism. They will swell when get enough moisture and will crack when it's dry. So when it's dry, they will not be able to function as a leachate containment or methane barrier. According to that background actually, next. Yeah. According to that background, actually, we try to do some research on liners that will incorporate some sustainable material. In this case, we try to use the coconut fiber. We try to use fly ash as a waste from the coal activities, and also we use dewatered salads to try to make some invention on the sustainable landfill liner. Yeah. This slide actually illustrates the structure of the landfill liner. At the bottom one, we have native soil, which is compacted up to 90%. And then we have clay. This is the normal structure of landfill liner. And then above the clay, we have the native soil, compacted native soil. We have gravel, we have geotextile. Sometimes we have geotextile soil. And then on the top of it, we pile all the waste that need to be treated in the landfill. But then, as I mentioned before, that the clay itself has a limitation related to the crack and swelling mechanism. So we try to develop, or we try to test some material that will have a possibility to be used as a liner. Next. Yeah. Basically, the result is quite simple. We try to do the preliminary testing, and also the preliminary testing actually consists of swelling testing for the bentonite. We use bentonite as a replacement of clay, and then we perform a standard Proctor test, we perform atomic limit test, and then for the main testing itself, we run a wetting drying cycle experiment, and also a direct shear, and we try to modeling or simulate the material using a GeoStudio. Yeah. What we are looking for our research, actually, basically, we try to see the plastic limit and liquid limit of its composite material. We call it composite material because in this case, actually, we try to mix all those material together, and we try to make one composite that can be tested and see the performance of those tested material. So we already made some variation. Actually, what we have done in one of research, we make like 5 variation of the material, and we also run all of those tests with the addition of bentonite. Bentonite will function as a replacement of the clay. and we try to mix together with a homogeneous mixture, and then we run the test for each of the variation. Next. So among all of those variation, actually, we try to incorporate fly ash as the main material. Fly ash actually is considered as waste coming from coal burning activities, normally coming from the power plant, and it's quite tricky to be treated. Some of them considered as hazardous waste, but some of people still accept the fly ash as a construction or replacement for construction material. So we try to incorporate fly ash in this research. We add with a certain amount of bentonite, but the percentage of bentonite is not that much. So the maximum is only 25% for the one of the mixture. And then we also try to add some fiber. The function of the fiber actually to prevent or to reduce the swelling mechanism of the bentonite. So we add, in this case actually, we add the coconut fiber. So we try to incorporate a local material into this mixture. Next. So after we perform the preliminary test and also the main testing, actually we also try to see the performance or the response of those 6 mixture according to wet and dry cycle. As we know that Indonesia has 2 seasons, the wet season and also dry season. And the response of all this material will be different depend on the season. So in this case, we test all this material in 2 conditions, the wet condition and also the dry condition. The reason why we test all this material in 2 conditions, actually we are trying to see whether any differences of response of the material, whether it will crack, whether it will remain attached, and what about the swelling mechanism and so on. So we try to see the response of those variation regarding to the wet and dry condition that we introduce to this sample. Next. The wetting drying cycle actually we perform in every 8 hours. We know exactly that in the real life, actually the wet dry session is not occurring during the days, but we try to speed up the process, and then we try to make the wet dry cycle every 8 hours. So we try to monitor the response of those sample when they are getting wet, and we try to see whether how much is the swelling, how much is it the changes in hydraulic permeability, and we also try to see is there any crack when we try to dry up the sample. So actually we found that this is the common finding actually, the higher the bentonite content, the higher the crack value. So because the bentonite itself is part of clay, and clay has high plasticity index, so this finding is quite common. And the second one, when we found that the lime can reduce the crack value, so addition of lime will reduce the crack of the mixture itself. While the coconut fiber can control syncrates cracking. So sometimes when the sample is dry, they will trigger crack, and the introducing of coconut fiber can control the syncrates. So I think this is quite an interesting result. And there is some variation that can be accepted to be used as a liner at the end. So in order to do the further research, actually we try to simulate or to compare with the performance of geosynthetic clay liner. So nowadays actually most of the landfill in Indonesia, instead of clay, they also install what we call geomembrane. But geomembrane actually got some limitation. and then the new technology coming, and they introduce go back to the clay material. They introduce what we call geosynthetic clay liner. Okay, so one of the drawback of this research actually, since we use a natural material, there is a problem with the durability of the material. So we also try to see the durability of the material in order to make sure that material will long last as expected. Yeah. All right, so next. Yeah. Finally, our research actually found that the mixture of bentonite, coconut fiber, lime has potential to be used as a landfill liner, replacing the geomembrane, replacing the natural clay, and also it has possibility to be side by side with geosynthetic clay liner. So since we use the local material, I think for the construction itself, the build cost and so on will not as high as if we import from another country. So this innovative waste-based material actually can improve crack resistance in liner, but in long-term system integrity depend on proper material selection. So it's quite important to select the material, protection layer and structural durability under real landfill condition. So the next research will be test those material in a real liner situation. Okay, yeah. We try to connect our research with the SDGs, the Sustainable Development Goal. So we found that this kind of innovation actually contribute to the clean water and sanitation, because the good landfill liner will protect the environment for any pollution. And the second one, it will connect to the Sustainable Development Goals number 9, which is industry, innovation, and also infrastructure, which is this kind of material in landfill structure. And the last one is also connect to the sustainable city and communities. As we know that to have a sustainable cities and to build a sustainable cities and communities, we need to protect the environment properly. So I think that will be my presentation for today. Thank you very much for your kind attention. I return back to Mbak Inge. Thank you, Mbak Inge.
Thank you, Prof. Arif. So from your presentation, we can say that water is not always water, right? But with a good treatment, we can change it into something better. Now we're going to move to our next speaker. She is a professor that learned about geotechnique. She learned about shake, shift, and challenge us to build stronger structure from geotechnique. Please welcome Prof. Rini Kusumawardani to present your presentation.
Okay. Thank you very much, Mbak Inge, Prof. Arif Budiarjo, and then also the participant of the conference, this conference this afternoon. Okay, for today, I would like. Okay, for this afternoon, I will present about our work of research with my partner, even not only my laboratory, but also my other laboratory in my university. In the order, I would like to show you what is the important if we are gathering, have a collaboration with other laboratory to improve our research and to solve the problem in the reality. And today I will take you through a journey that connects Indonesia unique geological setting, the seismic hazard arising from it, and its innovative engineering method to enhance the resilience of our infrastructure. And my presentation this afternoon is about a lesson from Indonesian seismic hazard to seismic health monitoring implementation for sustainable construction. And maybe it would be a little bit, not many people know about the seismic health monitoring and what we can support in civil engineering project, civil engineering background to support to have the good resilient infrastructure. And maybe before I come to my presentation, I would like to show you about the introduction of plate tectonic. Yeah. Okay. This is introduction to plate tectonic. How we can, I would like to introduce you how the earthquake could be arise, could be occur in the earth. And we can see here in this video how the young Earth, our planet, is built. And with this video, we could understand the foundation of seismic activity, particularly about plate tectonic. And you can see here that our planet, it divided to be different plate tectonic. And this crack formed to the boundaries that can trigger the earthquake. And we can see here, but in the bottom of the earth, we can see the magma, and the process of the magma, we can see here that the magma is always have the works, and this work, they try to release their energy into the surface of the earth. And this release of the energy makes the movement in the surface of the earth, and it trigger the phenomenon of the earthquake. And we can see here, these plates are constantly moving, and their interaction, whether they are converging, diverging, or sliding past each other, and it generates stress and release energy in the form of seismic wave. And you can see here how the mountains rise. And the movement on the continents joint, it could be trigger the phenomenon of earthquake. And from this video, we can see that all of many disaster in the earth, like an earthquake or tsunami or maybe volcano, it's like a system from the earth, how the earth can release the energy and make this phenomenon is stable. And then after this, I also want to see you the tectonic time lapse. From here, we can see that the plate tectonic is not stable. It's always move every second. That's why in Indonesia, we can see here, Indonesia, we have sit in the three boundaries of plate tectonic, Indo-Australia, Philippines, and also India. And it's make the why our Indonesian country is occur the earthquake very high frequently. And then after this, after we have know about the earthquake system in the earth, we can see that here, when the earthquake occur, energy is radiated from the fault in the form of seismic wave. And however, these waves do not travel uniformly. They behave differently depending on the soil layer, rock types, and topographic feature. And soft layer can amplify shaking, leading to more severe structural impact on building and bridges located above them. Meanwhile, the bedrock tends to transmit wave more efficiently with the less deformation. And from this picture, we can see bedrock tends to transmit wave more efficiently with the less deformation. And recognizing how seismic wave propagate through specific ground condition is crucial for designing infrastructure that can withstand the earthquake. So from this picture, we can see that the surface wave, they can propagate from the bedrock to the surface soil. And this wave could be amplified and it make the transfer, the surface, earthquake surface can make the infrastructure above the soil to have some effect. And from this picture, we can see the Indonesia seismic wave. And from this map, we can see that the seismic map highlights the extraordinary level of earthquake activity across Indonesia. And the concentration of events align with the tectonic boundaries, such as the Sunda Megathrust, one of the most active subduction zones in the world. And this red marker represents the thousands of events recorded over the years. This dense seismicity reinforce the importance of integrating earthquake engineering, resilient design principle, and continuous structural monitoring into our national construction practice. And this map until now is still used for us to try to design the construction, civil engineering construction in Indonesia. And from this kaleidoscope, it's released by BMKG, we can see the earthquake event in Indonesia in the year 2024 is almost received in the incident 7,000, more than 7,000. It means that every day we have more than maybe 20 incident of earthquake in Indonesia. It's from this we can know that Indonesia is in the area with the high prone active earthquake. And we can see here after we know about how the seismic wave propagation in the soil layer beneath of the soil. We can see here. We can see that the soil they travel through the different soil layer, causing the variation in shaking intensity. Such analysis help us to identify zones with the high liquefaction potential or area that may experience amplified ground motion, and they are essential input for designing safer infrastructure and developing disaster mitigation strategies. And this is my analysis about seismic wave propagation, because I tried to make analysis from one district, Balaroa, to the Petobo district. We can see here in the left side, this is the recorded seismic motion at Balaroa surface, yeah. And we have to know. I would like to know how about the seismic wave in the Petobo surface, because usually in Indonesia until now they always use the seismic wave data just only basis on the one accelerogram or one seismograph, and then they use for the other city or another site. But it directly is not quite proper, because the set soil layer of this set and other set is different. We can see here in the left set in Balara surface, and then I would like to know how about the seismic wave propagation in the Petobo surface. And from this research, we can see that in the Petobo surface, the amplification of the soil is more higher compared with the Balaroa surface. And from this analysis, we can see, but every site with the different layer, with the different topographic system, it would be have trigger the different seismic wave propagation. And the seismic wave propagation is very important for us, how to design the building to resilient from the earthquake phenomenon. And we can see here how the earthquake effect to the many construction civil engineering. In the left side, we can see here how the Petobo Palu flow liquefaction can occur. Yeah, it's not the landslide, but it's the flow Palu liquefaction. Actually, when the earthquake is not occur, the soil is okay. But when the earthquake occur, it could be to be the liquefaction. And then we can see in the central of the video, actually the earthquake is occur in Myanmar, but the building collapse, it's appear in Bangkok. Can you see the distance between Bangkok and Myanmar is quite far away, but the earthquake of Myanmar could be give effect to the Bangkok building. And then in the right side, we can see here that the brick of bridge between building, yeah, because of the earthquake, the building is pounding, yeah, pounding in the left and the right, and we can see here when the frequency of the pounding of the building also could be give the we have make sure that the building still stable or still safe after the earthquake. Yeah, and then after we know about how the earthquake seismic wave propagate to the soil, and then how the seismic wave have the effect on the building, I would like to have to propose all of the participants about the structural head monitoring system or SHM, and this. Structural head monitoring is very useful and very important for Indonesian construction building. Because why? Because after we got the seismic phenomenon or seismic disaster, we still have to know how about the system of the building is still could be safe to be occupied or not. And then we can see in the right side. Yeah, and then we can see here in the right side. Yeah, in the right side is the bridge in the London. It's built in 2000, and we can see here that the bridge is have some swaying like this, not not of the earthquake, but just only because the footage of the passenger who crossed the bridge. It's also we have to be make concern for this construction, because we have to do something. What should be we give to this construction to make this construction should be safety for the passenger. And this our work today about the structural head monitoring system in Kalipancur Bridge. We would like to introduce about this system to the government or also the agency who have the responsibility to know how or to manage how the system could be quite useful. And for this structural head monitoring in our work, we try to install the velocity meter sensor in the bridge, and we would like to know how about this bridge could be having the good safety or good work about this construction. And we try to compare with the as-built drawing bridge, and then we make the finite element model in our software to know that result of the structural health monitoring could be done and can be applied or could be implemented as the baseline of the model. And this is our work in the field, how we try to monitor or how we try to collect the data about the frequency. And this is the result of the measurement, and we try to make the result about the velocity and the velocity domain. And this is the result of the fast Fourier transfer in the amplitude domain for us to know how about the amplitude when this bridge could be passed by the vehicle. And this is the result of the analysis. We can see here from the numerical analysis, we can see from the identification step, we have the frequency is 3.1 Hertz. And then we try to compare with the finite element model, we have the 3.14 Hertz, and the deviation between them is just only 0.5%. And this is the result for the analysis. From here we can see the black note is our identification or collected data in the field, and the line is our finite element model. When the black note and the line have the same place, it means that our model is right and could be used to be the baseline. And after this, maybe if the government or the agency would like to make identification again in 5 years or 10 years again, we can see is the value is still the same or the value have the deviation. If the value have the deviation, it means we have to do something more. And this is also the experience about Tahoma Bridge failure. We can see here the Tahoma Bridge failure in America. The failure of this bridge is not about earthquake or people footage, but it's about because of the wind. The frequency of wind and the frequency of the bridge have the same value. And us, for the engineering designer or civil engineering consultant, have to make sure that the frequency of our construction should be not to be the same with maybe the frequency of earthquake or frequency of wind. Because if they have the same frequency, it means to be failure could be occur. And this is the conclusion for my presentation. This study is understand the critical importance by integrating seismic Hertz understanding with advanced structure monitoring technologies to enhance the resilience of infrastructure in earthquake-prone region. And the application of structural health monitoring system demonstrate how a real-time vibration data and finite element model can be effectively used to detect structural responses and validated design assumption. And the third, by bridging geological insight with structural engineering and innovation, the construction industry can transition from reactive to proactive risk management strategies. This integration not only improves public safety, but also aligns with the broader vision of building a sustainable and resilient construction future. And thank you very much.
Thank you so much, Professor Rini, for your insight presentation. We can see that we have to face the uncertainty of shaking ground, shifting slope, and also our natural phenomena in our structure. Now we're gonna move to our online speaker. Our fourth speaker will tell us about the roads that we travel every day, the roads that tell story of movement and connection. Ibu Zuni Nurhidayati, has she stayed in the Zoom meeting?
Yes, I'm here. Can you hear me?
Okay. Do you ready to present your presentation, Miss Ibu Zuni?
Yeah, I guess so.
Maybe you can start to share your screen.
Okay, let's start the screen.
Meanwhile, we are waiting Ibu Zuni Asih to start her screen. I would like to inform that Ibu Zuni Asih is a PhD student from Grand University. Ibu Zuni is a researcher in a road and bridge engineering with expertise in asphalt, pavement technology, and sustainable construction material. Her work explores innovative asphalt mixture, durability improvement, and environmentally conscious pavement that support long-term infrastructure resilience. Now, Ibu Zuni, you have 20 minutes to present your presentation. Thank you.
Thank you, Mbak Ina, for the warming introduction. Selamat siang, Prof. Ari Budi Harjo. Selamat siang, Prof. Rini. Good afternoon, distinguished colleagues, guests, and members of the organizing committee. To make sure, is my voice clearly?
Yes, we have seen your screen. And your voice is clearly.
Perfect. So I can hear the double sounds. Okay, now it's good. There is such a valuable opportunity to share our recent work at the first International Conference on Construction Innovation 2025 with Politeknik Public Works today. So for these sessions, I'm pleased to present our work with the road pavement material. Of course, we know it within the years. We call it asbutan, and then it is a valuable natural rock asphalt from Indonesia. So I would love to share with you today. Here we go. Before we begin, I'd like to mention that today's presentation is grounded in our most recent publications, a systematic review that we complete this year together with my colleague from Gadjah Mada University, ICOM UK, and the National Cheng Kung University. So if you want to deep dive into our paper, please feel free to reach out. And then here you can see this already published within the publisher Taylor and Francis with the journal Road Materials and Pavement Designs. Okay, what we can see in this slide is why the natural rock asphalt or Butan rock asphalt, or we know it as asbutan, matters. The global pavement industry is really continually seeking innovative and sustainable materials. And of course, at the same time, the roads sector is asked to find the new material that's still going on and would focus on the circular, economical. And also we have to know that we have to reduce the carbon emissions. And also we need to improve the circularity itself. With this scheme under the backgrounds, we know that Indonesia import over 700,000 tons of asphalt in 2024. And it also value around 8 to 10 trillion rupiah per year. Yet asbutan supplies only 5% domestic needs. It means that even though the country holds over 600 million tons of natural asphalt, it's still we need to find the lack of the gap itself. And among of this, a natural rock asphalt as the unique material known as asbutan has garnered attention in recent years. On the map, you can see the location is in the South Sulawesi in Indonesia, and the unique material asbutan is the largest deposit of the natural located in two islands, Kabungka and lavele. And on the right side, you see how different the form or the physical blocks looks like in reality. Lavele tends to be shiny and then conglomeratic, and kabunga is harder and fine grained. As you can see in here, the difference between those blocks of kabunga and lavele. And what kind of a study in our paper? This is about our paper bring about the bibliometric systematic review, and also we are using the Prisma method. We try to find and figure out what kind of a major trends arise, and then we found that after study 2015, speaking at the 40 publications in 2020, it employs a combinations of 200 more papers, and there's a rise four kind of a theme in this part that is a characteristic and forms of Ashburton itself, and the performance in different asphalt system, and sustainability, also in the environmental impact, as Prof. Aribudi just said, about a lot of sustainable topic in there. And finally, the challenge and future directions. We also map trends in keywords, material forms, and global research distribution. So hopefully this study is beneficial for the practitioner, academia, and also for the stakeholder in the public government sector. Here you go, you can see the results show that notable concentrations of contributions from still, it is from Asian countries. You can see that Indonesia reached like 55% publication for the papers about the aspartame, and then the China itself, it's reached 37%, with the attention still coming from the other countries like Japan, Malaysia, Australia, and the United States is still increasing there. And we can see also with the topics, most of them, the dominant themes includes the high temperature performance, biological behavior, fatigue and stiffness, and rotting resistance. What this suggests is that aspartame is no longer a local material. It is a part of the global conservations on sustainable pavement technologies. And this is the shape or geological origin from the aspartame. With this, we can see from the shape itself, the material is composed of natural bitumens and mineral ash. You can see in here part in the left side, the bitumen contains of 51% of asphaltenes, much higher than petroleum bitumen, and that's why it makes the asphalt itself inherently stiff, strong, and resistant to deformations. And it also contains the resins. Fractions contribute to flexibility and moisture resistance, but may reduce the workability, and we also have to maintain the dosage itself. On the other hand, you can see the mineral ash on the right side. The mineral ash, it's come like a rough or honeycomb texture, increase the interlocking and the adhesion itself, but can also mixture more brittle if we are not properly balanced in the mixture. And in the other words, it behaves like a built-in modifier. It also provides the strong structural benefits, but dosage and processing are the key among all of the mix design itself. So here we go, we can jump on to what kind of a product of the aspartame, what we have so far. Let me tell you the story about the production process itself. So aspartame comes in different forms depending on how it is processed. It is processed in the asphalt mixing plant and through a series of selection, crushing, and drying of the raw material. And from the raw blocks, it becomes a granular aspartame, and then semi-extraction and full extraction with the help of some base solvent materials. So it contains of two types of the block, kabunga and lavele. Each of this block also has three types of the product itself. The first one is the granular forms, is corresponded to 5 to 20. So it means that if you reach the penetration value, the minimum is 5, and the bitumen itself contained in this Buton granular asphalt is around 20%. And also the most common product in this part. Meanwhile, for the semi-extraction, it is partially purified, utilized as an additive, since it can improve the consistency and the workability. Also, with the full extraction, the pure bitumen, it comes from a Laville mine with the pan, it's equal with the pan 6070 or the 8000, and this full extraction is rising trend. I also use the pan 8000 in my research currently with the reclaim asphalt, and it's also driven the idea about using this natural rock asphalt. So each form has a unique performance characteristic, and many consistent research in the literature happen simply because of the different form we use. It's emphasis that the importance of the standardizing characteristics before the mixing part. So, well, how about the performance mechanism? Of course, we are end up with the 3 types of considerations. We connect with the physically and chemical in the shape. Physically, the interlocking mineral matrix increases stiffness and rotting resistance. The unique properties, the S fraction may significantly influence the properties and performance. Also, when we want to compare with the ordinary mineral fillers like limestone. For the chemical side, high asphaltene increase the viscosity, adhesion, and moisture resistance. And for the information, what kind of a chemical inside in this asbeston, we found that among of the literature review, we found that there's a paraffin, we have the acidapine, and then pectin, a sticky substance in those parts. And for the mineral component, there's a silica, alumina, calcium oxide, and it's also contribute to the stiffness itself. So these 2 mechanisms explain why asbeston performs extremely well at high temperatures, but reduce workability at a high dosage. So the balance is among most of the theme among the mixture design to get the higher performance for the end of the result. Here is, we can see by reading all of the papers published, there is physical and rheological properties, and it's extensively studied for their impact on the bitumen performance at both high and low temperature. So when asbeston is blended with the refinery bitumen, it makes the softening point is a rise. As you can see in this table, there's a viscosity also increase, and the ductility also decrease. And the multiple stress creep recovery, or MSCR, and lower uncoverable creep compliance also decrease, reflecting a showing improved rotting resistance in this part. But what we can see based on this table is it shows that asbeston acts as a natural modifier. It improves the high temperature performance while reducing the flexibility itself. And how, if we want to compare the petroleum-based asphalt mixture, is it different, or is it quite numerical, or have another beneficial in this account? At the mixture level, the trend is quite clear. So the stiffness, stability, rotting resistance, and fabric performance, it improved at the moderate dosage. And also the moisture resistance is still stable or slightly better depending on the aggregate type. Meanwhile, we find that wheel tracking test shows that up to 20 or 70% reductions in rut depth after 10,000 passes. So the dynamic stability also improves by nearly 100% compared to SBS modified asphalt. And fatigue performance is generally better with this asbeston, especially under the repeated loading. And long-term aging, freestyle cycles, and solve environments also improve. But at high aspartame content, we have to be careful with the cracking risk increases also. Workability decreases and sometimes segregations occurs. This again reinforce the need for proper research and mixture design control. And what can we get from the practical implications? Of course, in the name of the sustainability, we have environmental side, we have economic, we have the part of the another practitioner. The role of aspartame itself, actually, it's very significant. You can see in the asphalt modification, and it shows that aspartame as modified with asphalt and has the UV aging resistance in high temperature performance due to the strong adsorptions and flow resistant of the ash particles, improve durability and performance itself. Conversely, the pure bitumen is not directly compatible with neat bitumen, but blending it in suitable proportion like 10% to 15% can yield modified asphalt with the performance grade of 64 to 22. And regarding with the climate suitability, we also find that it's ideal for the hot climate like Indonesia. And the doses and mix design also, it's moderate if to give the best balance. The blending sequence and the temperature must be controlled. And for the construction, this is the highlight for this study. The higher viscosity require careful handling, and semi-extraction product often mix more easily at the plant level. These considerations are essential at the real-world implementation in the field. So what kind of a material that work better or really good compatible with these wood materials? First with the wrap, reclaim asphalt. It compensates for age binders. With the bio oil, as you can see, it improves high temperature performance. And with SBR, with the rubber and the basalt fiber, it also crack resistance increases. With the nanomaterial, nowadays the nanomaterial topic is really arises. In here, we are using the nanosilica and nano calcium carbonate. It also useful for the stiffness and moisture resistance for the improvement. This synergy suggests that aspartame can be integrated into broader sustainable pavement strategies, not as a standalone material, but a part of the modern material within this ecosystem. And here we go with the sustainability aspect. As we can see, when we want to see with the environmental aspect, aspartame reduce the dependence of the fossil bitumen and also can lower the CO2 emissions when performance is equivalent. For the energetically, the forms require the granular, it's require no high temperature polymer style processing. And the economical side, aspartame has potential to reduce the binder costs and improve long-term durability, especially in the rotting-prone areas. And local resource availability also give Indonesia a strong strategies advantage. Nowadays, there is several stockpile. I got the information from Bapak Dwi Putranto with the ASPABI. It's provide their product within several area. For instance, in near Semarang, we have that too. The stock in there, and then is it working with the current project? Yes, I see that in 2025 there are several projects in road project. They have like more than 27,000 tons nowadays, and hopefully it will be increased in the future on. And most of the product use in fabric, there is some extractions or B520, 5 to 20. Yeah, so hopefully we can see a lot of project with aspartame in the next year. After telling all of the beneficial or advantages with the aspartame itself, we faced the challenge and limitations. The first one with the workability and stiffness issues at high dosage. And how about despite of 198 studies we read, the gap still remain. Is that one, the natural variability between deposit and also the compatibility issues in batching or mixing. And it's also need limited long-term field data and observation. So we need kind of a observation during the several period time to see whether it changed the performance itself. This gap shaped the roadmap ahead, and addressing this gap is essential for the mainstream options. The last two part, the compatibility and field data and standard, we know that it's still limited in performance. What kind of future research direction we suggest that, according from the database, we found that looking ahead, we need to pay attention with these 5 areas. There is some material innovations, full extraction, composite modifications, and standardized grading. And also for the pavement performance, we need a long-term trial, as I mentioned before, accelerated the testing itself, and the low temperature cracking studies. For the sustainability and circularity, nowadays the era of a life cycle assessment is everywhere. But the thing is, we have to pay attention with the uncertainty and the data itself, because if we, for instance, if we are using a CIMA Pro or OpenLCA, most of the database we use for the EPG is using the EcoInvent. And for Indonesia case, there is still limited data inside of the database. So we need the assumption based on the field observation. Hopefully we also can get that one day by day with a full LCA comparisons and integration with the wall mix asphalt technologies, because it's a low temperature itself, but it has a light kind of a lot of limited or limitation for the process. And for the economic and supply chain modeling, national scale cost benefit and logistic optimization also needed in this part. The last one is the policy industry implementation. What I heard about this thing is a lot of demand of the asbuton itself, the product, especially for the availability within the road project. But the thing is, it needs more than the expected volume for one project to another project. So here we hope that the harmonized specifications and QC/QA frameworks also built in this kind of a scheme. This direction collectively define the roadmap for advancing aspartame as a modern pavement material. And the key insight of what kind of the takeaways that I observe is aspartame is unique, a natural composite with high asphaltite and minerals. That is the properties of itself. And the performance also improves, especially rutting and stability at the moderate dosage. Forms matter, but it is with the granular or semi-extraction and full extraction behave differently. And the research opportunities remain, especially yield validation and synergy with other materials like reclaimed asphalt, or what we see about the WEMA, or about the rubber itself and modern modifiers. There's a lot of modifiers, bio oil and other things, nanomaterial. So this is the key takeaways from this study. Now we talk about the almost finished this presentation is local context. What we have done so far, Indonesia already has a strong specification for this framework, from B5020, B5030, granular asbutan, and then to hot mix, modified hot mix, and CPHMA, co-pave hot mix asphalt, and many ways regulatory readiness is already there. The opportunity now lies in aligning material characterization, mix design itself, construction practice, and the quality control. And of course, the availability within the project. Is it enough for all of the road project or not? So that is the kind of the local context we observe so far. Uh, to I hope this synthesis of the review contributes to a clear understanding of hospital, not just as a national resource, but as a viable component of a sustainable pavement engineering. And it is such a kind of a story. It is a scientific potential, local strength, and the opportunity for innovation. And I believe that the practitioner from Bina Marga have a lot of experience with this material. And it's also opened the collaboration with academia itself. For instance, nowadays, I know that we, Ministry of Public Work, have a collaboration with the Korean South Korea Institute. We apply some case study in Atbutan and Wema. Let's see how it will be resulted in next month or next year. So if you like to explore the paper for further discussions, I would like to be very happy to be contact. Thank you. Bye, Inga. Back to you. Hello, but I can't hear the voice now. No voice, right, Mas Rian?
Yeah, I
Okay.
cannot hear anything.
You cannot hear anything. Maybe the sounds in the auditorium might be improved. Sorry, Mbak Inga. The audio might need to be fixed
Mantasa, yang Bapak Rian
because
Mantasa.
I can't hear. Ah, now it's good. Okay.
Okay, now we're going to our final speaker. He is someone who's worked to connect nature and engineer with a real-world application. Please welcome Bapak Rian Mantasa Salve Prastika.
I'm standing here on Concrete River and we cannot see any fish here. Do you ever notice how lifeless it feels around this concrete river? These concrete rivers degrade water quality and destroys aquatic habitats. In Jakarta, 1 out of 5 babies living near concrete rivers died from diarrhea in the last 5 years. Shocking, isn't it? Developed countries are reversing this trend. Australia has invested $200 million in restoring urban rivers with native plants and wildlife. But what about developing countries with tighter budgets? Before committing to extensive field projects, my research used numerical modeling to explore how vegetation can help naturalize rivers in a cheap way. Laboratory data validate these models where the lab environment imitates the river and vegetation, and fieldwork in Brisbane provides a real-world lab to learn from. River naturalization is not just about the environment, it's about healthier communities.
Okay, good afternoon, Bapak Rian.
Yeah,
you
good
hear
afternoon,
us?
Mbak Inga. Yes.
Glad to see you again.
Yeah, it's a very long time not seeing you. Oh my god, I'm very nervous.
So do you want to start your presentation?
Yeah. Okay.
Okay. While we are waiting your share screen, I will try to read your profile. Bapak Rian Mantasa is a researcher in urban water engineering focused on nature-based solutions for river system in Brisbane and Indonesia. With a passion for integrating ecological approach into conventional engineering, their work centers on urban stormwater management and river naturalization, particularly particularly the interaction between water, sediment, and vegetation during both dry and flood condition. With Parian Mantasa, you have 20 minutes to present your research. Please give big applause for her, for him.
Okay, good afternoon, everyone. So, thank you for having me in this wonderful opportunity. And also, it will be very amazing to have one session with amazing speakers like Prof. Arif, Prof. Rini, and Buzuni, who had more experiences than me. So hopefully I can make it balance with my presentation today. So let me share my screen first. Make it a little bit difficult in my screen. Well, can you see the screen? Can you see the slides? By me?
Yes,
I
it
think,
can.
yeah.
You can clearly.
Okay. Wait. I have a little bit technical issues here. Let's stop first.
Do you have a trouble, or do you mind to share the presentation from our committee?
No, I'm good. Can you see my slides now?
Yes, we can see your slide.
Okay.
But this is
I
not in a
think
slideshow.
Oh, okay. I think that's the problem. Wait. How about now? Is it in the slideshow? Yeah, hopefully it's in the slideshow. Okay, good afternoon, everyone. My name is Sian Matasa. I'm from the University of Queensland. Today, I would like to present my research entitled Nature-Based Solution for Indonesia.
Bapak Rian, this is
Yep.
still not in your slideshow mode. Or do you mind to our committee to help you share screen?
What? I think. Oh, I forget to share the screen through Zoom. Can you see now for the slides?
Okay. I think it's okay, Mr. Mantasa, even it's not in the slideshow mode. But we can still read it clearly.
It's not right.
Maybe you can choose to share your entire screen, and then you move to your presentation and the slides and the slide presentation.
How about now?
Or do you mind if the operator will share your screen, Bapak Mantasa?
Is it still not working
Yeah, it's working now.
in the slideshow?
Yeah, you can start your presentation.
Oh, okay. Okay, sorry for the technical issues, everyone. Yeah, so basically, I would like to present some of my research here. So firstly, I would like to tell you about the global water ecosystem problems and the solutions. So I have some examples of the problems and solution, not in Indonesia, but also in the world. Eco-hydrology as nature-based solutions, eco-hydrology around the world and Indonesia, problems in Indonesia and lesson learned from Australia, future challenges of green infrastructure, numerical model of flow vegetation interaction for green infrastructure, and also the closing remarks for this presentation. Okay, I will start with our global water ecosystem degradation. We will agree that not only in developing countries, but also in the developed countries, we have the same problem of the water quality and water quantity. We can see here from this picture, actually the climate change impacts on water quality. We have a lot of flooding problems in Indonesia, in other countries, even in developed countries, they have the same problems. And also the other problem beside the water quantity is the water quality. We have bad water quality because of urbanization, because of farming activities. So all of these activities that created by human base attract degradation for the water quality in the environment. So that's actually what we face today, not only in Indonesia, but also around the world. What can we do now? If we learn in our, in the university, we usually propose by technical solution, like engineering solution, human-based solution. However, on the other side, actually, some countries, especially in developed countries, they already try to initiate a solution that we call it as nature-based solution or NBS. For example, here we have several beneficial aspects that can be gained from the nature-based solution. For example, we have more positive impacts on ecosystem, adaptable and resilient structures, and lower economic costs compared with the gray infrastructure, or maybe we usually known this solution as engineering-based solution. It may have short-term results, negative impacts on the ecosystem where they are implanted and adjacent areas, and also some structure are non-resilient, and also it's high economic cost. So that's basically the basic comparison of traditional and nature-based solution. And the nature-based solution that related with water-related problems, we call it here as ecohydrology. We have the specific terms in our field that called ecohydrology. So ecohydrology is an integrative transdisciplinary science providing nature-based solution not only for reduction of existing impact on aquatic ecosystem, but also for the enhancement of the sustainability potential at the catchment of the future. We can see here in the graph, we have the ecosystem threshold for self-restorations, and also the goal of the eco-hydrology itself, it can increase ecosystem carrying capacity. If we see more details about the eco-hydrology core and principle here, well, actually, we have a lot of phenomena in this diagram. We can see here in the bottom left, we have the hydrologic cycle. We have evapotranspiration, total runoff, surface runoff that are really connected with our problems, the quantity and the quality of the water in our environment, because we have the flooding because of we have the higher intensity of rainfall. We have bad water quality because farming activities, industrial activities, urbanization activities make the water becomes not good anymore. Something like that. So the solution that is proposed by the eco-hydrology ecosystem here is there is a dual regulation. If you see the triangle in the middle, it is the hydrological, ecological engineering, and ecological becomes one solution that makes our solution towards the engineering problems, especially in water engineering, becomes more environmental friendly. This is the problem that I found in Indonesia here. Actually, ecohydrology is very emerging field, not maybe not in Indonesia, but in the other part of the world. There is still limited experts of field study specialists of ecohydrology, nature-based solution in Indonesia, and there is still only one ecohydrology demonstration site in Indonesia, that is Subak Bengkel in Tabanan, Bali. So that is the motivation that I would like to learn from other eco-hydrology experts around the world, how they tackle the water-related problems in their country. And then maybe I can learn somehow from them about the solution that they use. So I flew to China last 2023 and met a lot of experts, especially in eco-hydrology. So maybe if you have any interest research area in the eco-hydrology field, I can connect to one of them. So in here, if you can see, there are 16 countries in Chile, Colombia, Ecuador, Ethiopia, Indonesia, Malaysia, Iran, and other countries here. So basically, they can collaborate with us in any kind of activities like workshops or conference like this, seminar, and other kind of activities that can support, especially Polytechnic of Public Works in the future in the field of education or research. I can connect them. But in here, I would like to show you what I learned from the countries that participate in these workshops, and how it may help our eco-hydrological field in Indonesia. Okay, so basically there are the countries that I get lesson learned from the workshops, and I will connect them with my research later. So this is the first example of eco-hydrology in Brazil. So we know that the water quality in Brazil in some catchment are very, very bad. And they use what we call it oysters to improve the water quality in Brazil. So we can see here that the total of the reservoir daily clearance was calculated around 30.2% for the total volume of the Vitória estuary. Not only Brazil, we have Nicaragua. We can see here that in the left picture, it is agricultural field, and we believe that agriculture also make our water quality worse because it attracts phosphorus, nitrates to the river, to the lakes, and makes our water quality becomes not good for environment or fish to live. So yeah, it works for the aquatic habitat. So that's why in Nicaragua, they implement a technology that we call it as phytotechnologies in ecohydrology, so it can improve the water quality in the river. So we can see here that there are sediment traps, and yeah, basically they use vegetation for the phytotechnologies in this site. We have also phytotechnology in Chile. We can see here that the Chile problems that we can see in the picture in the left is the erosion from the slopes and the upper part of the watersheds due to deforestation. And in the right side there, some of ecohydrology experts already implement the phytotechnology and then do the reforestation and management and conservation, and it makes the catchment becomes better. No, that's the example of the phytotechnology in Chile. Ethiopia also implement the same thing. What I can learn here is there is some vegetation with different kind of species, because the research said that different species of vegetation can help to improve water quality in different level. So we have papyrus here, we have floating grass, we have taipa. So basically, river from the catchment will be treated in this kind of integrated sedimentation by filtration treatment effluent before they are going to the river. If you can see the inlet and the outlet, that's how the flow direction will make the water treated in these filtrations. Also, the other restoration that I can show you here is from Sri Lanka. So in the picture in the left, it's some field work from my college, Darshania, in 2017. And after the restoration of the wetland in Sri Lanka, it becomes, yeah, you can see the difference, right? There are many trees in the left, and in the right, there are many aquatic habitats that becomes, yeah, it becomes the healthier environment compared with the left one. How about Indonesia? So that's what I would like to talk in this presentation. We can see here that there are a lot of problems in Indonesia. As I said in the earlier presentation, that the two problems that related with water are water quantity and water quality. Water quantity, we have problem with water availability is critical. And then when the rainfall comes, we have flooding. And also, if we talk about water quality, we have heavy polluted river. It's almost 68%, not only in Java Island, but also Sumatra. Kalimantan, Sulawesi, we have 51% of heavy polluted river. And yeah, basically that's the problems in our islands in Indonesia, and how we can implement the approach of nature-based solution of eco hydrology in this country. Actually, it will be beneficial for the environment in the future in Indonesia. But we cannot deny that actually there are some experts in this field already implement the technology in some areas. Then I would like to show you the examples. The first one is eco-technology constructed treatment wetland in Maninjau Lake, Indonesia. So Maninjau Lake, according to the research, they have very bad water quality in the past, and after some researchers in the limnology and also ecohydrology created the constructed treatment wetland. So this is the modular construction, and also it can be very beneficial for the microhabitat, right? We can see here there are some fishes, there are fish eggs, there are shrimps actually. And the strength of the constructed treatment wetland here is it can remove 60% of total suspended sediments and nutrients in the lake. Okay, the other example here, I got it from my colleagues from Gadjah Mada University. This is located in Jogja. We can see here, this is the river. And if I can play this video for you, you can see when the rainfall happens, the river can enhance its capability, to accommodate more water. And after the rainfall stops, the river becomes normal again. So that's actually one of the example of how we can use the nature-based solution approach to solve our problems related to water. Okay. Yep. Okay. Talking back to the problems in Indonesia, we can see here a picture. I got it from VOA News. We can see here that there are two problems that we can see in the same picture. The first problem that correlated with the water quantity is flooding. The second one is water quality, is the bad water, the bad environment. We can see that it's brown, and then maybe if we can smell it directly, maybe it's not that good smell. The picture here actually the aerial image of the normal river in urban areas, especially in Jakarta. But actually, I can say that there are some rivers in other cities in Indonesia also have the same structure like this. If we see this picture, actually it's very normal, but actually the concrete rivers in here, according to some research, attract environmental drawbacks for our environment. The first one is the river with concrete like this can create high intensity of sediments, and also it can attract the extinction of aquatic habitat, and also it makes the degradation of water quality. So that's why some rivers in developed countries already transform or change from this concrete channel to the naturalized channel. So they restored the river from concrete to the vegetation one. If we can see the example of the Ario Seco project here, we can see that in the past, the structure of the river is like this, very straight with concrete, but in the following years, they realized that this is not good for our environment, this is not good for our fishes, this is not good for our aquatic habitat, this is not good for our quality of life in the surrounding of the river. So they transformed the river from the concrete to the more naturalized one. So they planted some vegetation, they planted some species that attracts more aquatic habitats and also attracts healthier life in the surroundings. So this is the example of revitalization in Brisbane, Australia. We can see here that compared with river with concrete channels, if we can see here that the rivers have natural channel, and we can see there are more aquatic habitats. We can see birds. We can see streams, fishes in the water. So that's actually what we want in our cities. That's what we want in our neighborhood, not like concrete rivers with bad smell. Why vegetation is important here? According to the research, actually vegetation can be used as engineering to trap the sediment. So the roots that can bind subtidal carbonate sediments and also aquatic vegetation as a trapping agent for flowing sediments. And also the research said that increasing the vegetation in the river 33 until 55%, it can enhance the ability to trap the sediments to 15%. And also the vegetation species that I show you the picture previously, different species can have different capability to trap the sediments. The sediment transport process actually is influenced by the flow velocity. So that's why if we have different species of vegetation, for example, rigid or flexible, the process of sediment transport, of the process of trapping the sediments also different. That's why choosing the perfect species of vegetation in a river will be beneficial if we can choose wisely in the planning. Okay, so for example here, I can show you, this is the difference of river in urban cities in Brisbane. So this is the picture 2013 in the left, and 10 years later, the river that firstly straight made from concrete, it becomes more, have many meanders and also more vegetation. But in here, actually, I can say this is very costly. So that's why planning or designing in the very first stage will be very important to construct channel naturalization. Yeah, so the concrete channel, a highly engineered condition characterized by concrete line channel with steep banks, and the picture the 10 years later, this is the waterway that mimics an undisturbed natural system that includes native vegetation, rocks, and boulders. Okay, the future challenge here that also part of the research here is the numerical modeling and field data. Why this is important? First, to transform the concrete channel river in the lab in 2013 to be in the 2023 in the next is very expensive. It's very costly. That's why it requires comprehensive planning, and the best way to do the planning in here is to do the numerical modeling that may help at the very first stage of the planning to design river naturalization before it is really constructed in the field. So in here, I did a pilot study to study the flow velocity, because I mentioned in the beginning that flow velocity becomes very important in the process of transport sediments, and also so the transport sediment also affect the water quality. So this is the pilot study where I use the clear channel. Imagine this is just concrete channel with straight, no vegetation inside the river, and in the second video, it is the flume with vegetation, artificial vegetation. So we can see here that the condition of flow velocity completely different. And when we collect the data in the straight channel without vegetation and with vegetation, the flow velocity becomes very different. This is the example of flow velocity in the straight channel without any vegetation inside the river, inside the flume. And then this is the example of flow velocity inside the vegetation. We can see here that there are two different types of patterns. So that's why, because of those flow velocity are different, it will affect sediment transport, and the sediment transport capability also affect the water quality. So that's why choosing the best vegetation for our river naturalization will be very important. Okay, what? Yes?
Yes. Maybe, I'm sorry to say, but maybe you have to move your presentation faster.
Okay. Yeah, so basically this is the numerical modeling that I use. I use the system modeling, and in here I can do the hydraulics, vegetation, inundation, and sea change, and other kind of numerical model. And also the field data is very important. That's why I choose Brisbane River that I show you in the previous video to do data collections. The collection here I use Rich RS2, water level monitoring, and flow velocity to collect the field data here. So basically, the analytical solution that I use here, I use a lot of equations and mathematical equation from previous researchers, and this helps me to validate the results of numerical model that I construct from the system that I previously mentioned before. So the final results I can show you. Yeah, this is the final result of study case A. We can see here that if among the lab numerical data and field data, they are in the same trend for the study case A and also study case B. So that's why in the future it will be good to do the numerical modeling first before it is implemented in the real case. Okay, for the closing remarks from my presentation here, ecohydrology is emerging globally as a core nature-based solution for addressing water-related challenges such as flooding, degradation of river ecosystem, and declining urban water quality. And numerical model provides a robust and forward-looking approach to guide the design of infrastructure and naturalized river system. And overall, advancing ecohydrology and modeling application in Indonesia and across the wider region can play a crucial role in shaping a resilient environmentally integrated water infrastructure for the future. Okay, I think that's all for my presentation. Thank you for the occasion. I will return this to Mbak Inga. Thank you.
Moving into question and answer session. After we learn about geotechnic engineering, environmental engineering, road, and also water engineering, I hope all of the people here will have a curious about something here. If you have questions, feel free to raise your hand. Please mention your name and affiliation before your question. Probably we will start this session with 3 questions. The committee, please help. Who want to ask first? Please raise your hand. Okay, this one, 1 and 3. Okay, 3 questions.
Okay, thank you for the opportunity. I would like to give a question for Prof. Rini. Thank you for the interesting research related to the structural health monitoring. Because actually I also have some issue related to the automation in construction, Prof. And I see have a correlation about you use the sensor, right, to give or to monitor the bridge and then to collect the data and something else. I already curious about how the next step after you use the sensor to collect the data, and also maybe which sensor that you use to collect the data, also to monitoring the condition of the bridge. Maybe that's my first question. Thank you.
Next to the, okay. Oh, no. Okay, now the second question in the middle, please.
Hello everyone, my name is Muhammad Bahtiar Akbar. I'm from Works and Bridge Construction Technology. How is leisure treated using open damping technology, and what is the lifetime of this technology? Thank you.
Do you ask this for all of the speaker or just some speaker? Mr. Arif?
Yes.
Okay, do you mind to? Okay, do you mind to repeat the question? Raga ya tadi ya.
How is leisure treated using open damping technology, and what is the lifetime of this technology? Bagaimana pengolahan air lindi dari teknologi open damping dan bagaimana dengan lifetime teknologi ini? Terima kasih.
Now we're gonna move to the third question.
Hello, thank you for the opportunity. I'm Mutia Fitrin Aini. I'd like to ask to Mr. Arif for the technology using the liner with bentonite itself. Is the waste material also can be used for any other materials other than domestic waste, such as like construction material waste, and also probably like chemical waste? I think, and also if the material could be changed to like some kind of concrete, does it also have other effect to the soil itself? Thank you.
So we have 3 questions. 1 question from Ibu Rizky Citra, for Mr. Rini, and 2 questions more for Bapak Arif. You want to answer? Yeah. Please, Ibu Prof. Rini untuk bisa menjawab.
Okay, thank you Bu Inge, and thank you Bu Rizky Citra. Nice to see you again. Yeah. Nowadays in Indonesia about the structural health monitoring is quite interesting topic. I mean a sexy topic for us because you know we are facing many challenging, not just only earthquake, but sometimes for maybe in a bridge or road we have the dynamic look like a pacing of the vehicle. It also we have to consider about how the structural health monitoring system can be implemented in this area. Actually, for the step for SHMS, structural health monitoring system, the first actually it's better if we try to checking on the new building or new infrastructure. It means we have the baseline first. We check the as-built drawing and we try before after they are constructed and we are not occupied first. We try to check by the sensor, velocity meter or accelerometer. We check how much the frequency of its infrastructure. And after this, after we checking in the field, we try to compare with the finite element model. If the finite element model and the collected data that we are trying to collect that is different, we have to try to change the finite element model. So the perfect data is from the collected data from the field measurement because the valid data. And the finite element we have need to suitable adjust it with the collected data from the field measurement. And after this, after we have the fixed data between the finite element model and collected data measurement, with the different deviation is not bigger, we can try to log this finite element model. And then this finite element model could be used as the baseline. It means that next time, maybe in 3 years again or 5 years again, we try to check the construction, the structure. We should compare the real collected data after 3 years or 5 years is still suitable with the baseline correction data. Normally in the country we have the seismicity, high seismicity occurrence. They try after the seismicity appear, they try to measure the structure and try to compare with the baseline model. If the baseline model and the field measurement, there is no many deviation, no high deviation, it means the structure is still safe. But if we try and we analyze this, the deviation is very high, it means something happened in this structure. In Indonesia, normally the sensor, there is many types can be used. For nowadays, many people they try to use the velocity meter or accelerometer, but they adjust, they install permanently in the structure. Like maybe I don't know, professor from Buntara from Japan this morning. Yeah, they also install the velocity meter or I forget accelerometer maybe in the building of in Jakarta, yeah, and stay like that. But in my laboratory, I try to use the equipment by handy carry. It means that we want to try this day or this moment. Now we can just install just only 15 minutes or 30 minutes, and then we just collect again and bring back to our laboratory. And next day or next time we try to measure again. Like that, Bu Citra. Is still okay? Thank you.
Now we're gonna move to our second and the third question For Mr. Pak Arif, silahkan. Prof. Arif.
Yeah. First, thank you for the question. I'd like to answer the question. I'm not quite sure whether I can get your question properly, but I try to answer what I understand from that question. First, you asked about the landfill, right? You asked about the lifetime of the liner. I presume that you're asking me about the lifetime of the liner. That has become one of consideration of our research actually. Since we deal with some organic material, so it's kind of related to the lifespan of the material itself. So I'm quite pretty sure. Pretty sure that during the operation there is some decomposition will be occur in that liner. But we're trying to see whether the decomposition itself will affect the function or the performance of the liner itself. So it's still a long-range process. It's still under research. So far, we got some positive result, but we haven't got the final. We cannot draw any conclusion yet regarding the lifespan of the material itself. So yeah, that's my answer. For the second question, actually, related to the use of other waste material as liner composite. Yes, there is some opportunity to use some waste materials to be combined with other material and use that material for landfill liner. But then it's depend on the nature of the material itself. Since the liner of the landfill has its own characteristic, so I do believe that choosing the proper material, for example, which waste material that will be used to be explored further for landfill liner will be like a quite challenging choice. The second one, is there any effect on the soil itself? Yeah, I do believe that it's depend on the performance of the liner itself. For example, in our research, actually, we use fly ash for the as a mixture. So previously, fly ash is considered as a hazardous material, and one of the concerns related to use of the fly ash is the leaching of the fly ash itself, and some people afraid the effect of the hazardous waste that has been released from the fly ash to the environment. But nowadays, actually, the Ministry of Environment in Indonesia has already excluded the fly ash from the waste hazardous waste classification. So I think whether we can still see the possibility of any change, any effect to the environment, but we do believe that we can reduce the effect as low as possible. So yeah, I think that's my opinion. Thank you for the question.
I hope I can give you more chance for question and answer session. But unfortunately, the committee said that the time is over. So we are going to close this session. As we close this invited speaker session, I want to thank to all of our speakers, both offline speaker and online speaker, for sharing their wisdom and passion. Thank you, Ibu Zuni, Bapak Rian, Prof. Rini, Prof. Arif. Today we didn't just talk about construction, we talked about the future, the one we dream of and the one we build together. Our speaker reminded us that bridging vision and reality takes courage, knowledge, collaboration, and belief that the world can be better than it's today. On behalf of this session, thank you for all of the speakers and all of the participants for being here, for listening, and for caring about our sustainable construction future. enjoy the rest of the conference. And the last, I want to give this session into the Master of Ceremony.
Okay, let's give a big round of applause. Thank you so much to our moderator and also speakers for the insightful session. May we kindly invite our honorable speakers and also moderator to move forward. Please kindly move forward so we can take a picture perfectly. And we will now proceed with the appreciation for our speakers. So we kindly invite Vice Director 1, Bapak Samsul Bari, to join us on the stage for the presentation. Ladies and gentlemen, as we conclude that insightful session, we would now like to take a special moment to express our deepest appreciation to our distinguished speakers. Their valuable insight, forward thinking perspectives, and generous contributions have enriched our conference and also inspired us to continue advancing innovation within the construction industry. To honor their dedication and remarkable expertise, we are pleased to present a token of appreciation in the form of a commemorative plaque. Let's give a big round of applause once again. This plaque symbolizes our gratitude for the knowledge shared today, and we hope it serves as a reminder of their meaningful role in shaping the future of sustainable construction. Thank you so much. We will take a picture together. Please kindly be centered. And open and also show the plaque to the camera. Give your best smile. And I will count down in 3, 2, 1. Smile. Okay, nice. Thank you. Let's give a big round of applause. Thank you so much to the moderator and also speakers. Please kindly back to your seat. Thank you very much for the insightful session. Distinguished guests, ladies and gentlemen, we will now take a short break before we proceed to the next session. So we kindly request all participants to remain and please stay here as the next session will begin promptly after this break. And we are going to announce best presenter and also best paper. So we kindly request all participants to please remain and stay here. Thank you very much.
Enggak, soalnya kan yang dari itu kan ada kayak citasinya. Saya ngambil dari video mana gitu loh. Takutnya nanti kalau dipublish, jadi nanti nanti saya kasihkan aja ke ini mungkin dibantu ini bisa nggak ya? Ganti videonya itu. Soalnya takutnya nanti kalau kayak di komplain orang-orang luar. Ya, gitu. Tak enggak, maksudnya kasihan
Okay, ladies and gentlemen, good afternoon. We kindly please you to back to your seat because after this, in 15 minutes, we will begin the event again. So I would like to invite all of you to please back to your seat because the event will begin in 15 minutes. Thank you very much. Good afternoon, ladies and gentlemen. To all of our distinguished guests, we are now entering one of the most anticipated moments, and we are going to announce the best papers and the best presenters. This recognition is given to the speaker who demonstrated outstanding delivery, effective communications, and insightful contribution during their presentation. And the award for the best presenter goes to 3D modeling based on Scan 2 BIM using terrestrial laser scanner as an initial step for BIM implementation in facility management at the Ministry of Public Works Case Study, Center Data and Information Technology Building. Congratulations to Muhammad Ihsan, Legana Rafa, Ike Marbun Rohma, and Zaki Naufal Aldi Putra. And we would like to invite the winner to come forward to the stage to receive the award. Congratulations once again to Muhammad Ihsan, Legana Rafa, Ike Marbun Rohma, and also Zaki Naufal Aldi Putra. Congratulations. Maybe the representative of the team can join us to the stage to receive the award. Congratulations once again. Please give me a round of applause. Congratulations. Yes, please kindly join us to the stage. Ladies and gentlemen, next we move to the Best Paper Award. These awards are presented to either outstanding academic contributions and exceptional performance on writing. And we will begin with the Best Paper Award. And the second runner-up goes to the performance comparison of GVRP and steel reinforcement on nominal moment and ductility in earthquake-resistant structures. Congratulations for Alfian Andika, Gomajaka, and Haryanto. Congratulations once again. Please join us to the stage. Alfian Andika, Gomajaka, and Haryanto. Congratulations once again. You got the second runner-up for the Best Paper Award. Congratulations. Please kindly join us to the stage. And now we're going to present it under Outstanding Academic Contributions and Exceptional Performance on Writing to the first runner-up. The Best Paper Award, the first runner-up, proudly present to Heru Trisaksena with the title of Assessing BIM Implementation in Indonesia's Road and Bridge Infrastructure, a key performance indicator-based evaluation. Congratulations once again. Please give a big round of applause, everyone, once again. Mr. Heru Trisaksena, please join us to the stage. And here we are going to announce the winner or Best of the Best Paper Award. Who will be the winner? Maybe we can guess it. And the winner, also the Best Paper Award, goes to, with the title of analysis of seepage based on Finach monitoring data at the Bilibili Dam. Congratulations to Karimatunisa, Muhammad Bagus, Wiratama Asad, Suripin, and Dia Ari Wulandari. Congratulations to the team to be the winner. And the best paper award, I invite a representative of the team to can join us to the stage. Congratulations once again. We kindly invite all winners to please come forward to the stage to receive their award. And also I would like to invite Head of Academic and General Registration Division of Bapak Wildan Herwindo to give the award. Excuse me, but where is the winner? Karimatunisa, Muhammad Bagus Wiratama Asad, Suripin, and also Dia Ari Wulandari. Okay, let's give a big round of applause, everyone. Congratulations once again to all the winner. This award is given to the speaker who demonstrated outstanding delivery, effective communication, and insightful contribution during the presentation, and also exceptional performance on writing. Congratulations for the best presenter and also the best paper award. May all of this award keep inspiring us to be better in the future. And for the representative of the winner of the Best Paper Award is being representative of Bapak Wildan Herwindo. Okay, please stay here. We can let you take a picture together to memorizing this moment. And all of the certificate and a plaque you can put in our committee and our team, so you can go for it. Three, two, one. Give your best smile. Okay, everyone, let's give a big round of applause. Thank you very much to all the winner. Congratulations. And for Bapak Wildan Herwindo, we kindly ask you to stay in your place, to remain on stage, because after that we will hear the closing remarks. So ladies and gentlemen, and also distinguished speakers, participants and honored guests, as we reach the conclusion of today's international seminar, we would like to take a moment to wrap up the insight, exchange, and collaboration that have been shared throughout the program. And to officially close today's session, we are privileged to have a special remarks with great respect we invite Head of Academic and General Registration Division, Bapak Wildan Herwindo, to deliver the closing remarks. Please welcome Bapak Wildan Herwindo. The stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. First time, I will give congratulations for the winner on this session of the first international conference on construction innovation, ICCI 2025. So, on behalf of Director of PUTEC Politeknik Pekerjaan Umum, I will deliver the closing remarks for the first international conference on construction innovation, ICCI 2025. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, good afternoon, may peace and prosperity be upon us all. The distinguished attendees, the rectors, directors, and leaders of higher education institutions, the organizing partners, the keynote speakers, Professor Indratmo Soekarno, Profesor Ji Haur Chen, Profesor Takafumi Nishikawa, Profesor Gan Buntara Stanley, Dr. Alwin Commander, and also the invited speakers, Profesor Arif Budiharjo, Profesor Rini Kusumawardani, Dr. Reyes Garcia, Rian Mantasa Salve Prastika, and Juniasi Nur Hidayati. All the distinguished guests, presenters, lecturers, and students. First and foremost, let us offer our most gratitude to God Almighty, because with His blessing and grace, the first international conference on construction innovation, ICCI 2025, with the theme Bridging Vision and Reality for a Sustainable Construction Future, has proceeded successfully, smoothly, and meaningfully. Dear ladies and gentlemen, our distinguished guests, today we have witnessed how international collaboration. We have 9 countries here, academic excellencies, and professional experience have converged to enrich our understanding of 4.0 technologies in construction, ranging from IoT, building information modeling, and artificial intelligence to drones and UAVs, as well as nature-based solutions, sustainable development policies, eco-friendly transportation system, water resources management, and disaster risk management. The discussion that have taken place in both the plenary and parallel session, we have 1 plenary session and 11 rooms in parallel session, have provided valuable insight for all of us in strengthening human resource capacity, promoting applied research, and expanding academic and professional networks. Please allow me, on behalf of PUTEC, to express our deepest appreciation to the keynote and invited speakers who have shared their knowledge and experiences, the reviewers who have supported the academic quality of the conference, the moderators who have professionally guided the proceedings, the participants who have actively engaged in discussion and provided contribution, and the entire organizing committee of ICCI 2025 who have worked tirelessly to prepare and carry out this event. May this conference become an initial step towards stronger collaboration, more in-depth research, and tangible implementation, leading us to a future of construction that is more sustainable, resilient, and inclusive. Dear ladies and gentlemen, our distinguished guests, should there be any shortcoming in the execution of this conference, we sincerely apologize. We hope that today's event will be beneficial for all of us and become an important part of our efforts to deliver infrastructure that is not only robust, but also environmentally friendly and responsive to societal needs. With praise and gratitude to God Almighty, I hereby officially declare the first International Conference of Construction Innovation, ICCI 2025 closed. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi Santi Om Rahayu, Semarang, November 27, 2025. Director of PUTEX, Insinyur Brawijaya, SE MNIE, MSCE, PSD, IPU, ASEAN Eng.
Thank you so much, Mr. Wildad Herwido, as Head of Academic and General Registration Division for your warm closing remarks. And ladies and gentlemen, this concludes our entire program for today. And on behalf of the organizing committee, I thank you all and also apologize for any shortcomings during the event. I am Reza Violentina as your Master of Ceremony, signing off. See you again at our next event. Thank you and have a pleasant day.